Did everyone, I guess anyone having problems finding this room? Should we send like a little map maybe? Anyway, I want to kick this thing off with welcoming everyone to ElixirConf EU 2023. Let's hear it. Now, first of all, let me apologize for my attire. A conference with a bunch of geniuses, and I figured, they're going to be serious, But so maybe a little too serious with my black attire. But just think of me as Johnny Cash. All right, we have a few slides here to go through. Welcome everyone. We want to first of all, I think we keep saying this, and it's true. We can't hold a conference without sponsors. We appreciate our sponsors, so we want to give them a big round of applause. We're going to start with our diversity inclusion sponsors: Fresha, Starfish, and Coverflex. Let's give them a big hand. And our platinum sponsors, YOLO, PepsiCo, and Teller. And our gold sponsors, LifeFlow and Erlang Solutions. If you're wondering what I'm looking at, this is like, so anyway. By the way, the sponsors are in Laundress, which is where you were at this morning, just down the hallway there. So please drop by their stands over the next 2 days. Okay, and then we have our silver sponsors, Main Matter and Bounce. Our group sponsor, Remote. I had to ask what a group sponsor was. They sent 35 people to the conference, so yeah, that's. I think there's a coup going to happen. I'm not sure. And our supporting sponsors, Erlang Ecosystem Foundation. Yep, go ahead. And the last one I want to call out. I'm looking at the camera. Turismo de Lisboa. Okay, so, and just for you, if you don't know anything about Lisbon, no matter where you're at, you should seriously consider taking your family and moving here permanently. Okay. All right, so now we're going to hear from a few of our key sponsors. And we're going to start with Camille Kowalski from Fresha.
Thanks. Let me put up my notes because I actually have something written, because I have a memory of a goldfish and attention span of a 2-year-old. Okay, great to be back. First of all, I'm Camille Kowalski. I'm staff engineer at Fresha, and we're connecting the world to beauty and wellness. So Fresha is, what is Fresha? Fresha is a beauty and wellness marketplace platform which allows clients to explore venues, book appointments, manage their appointments, take payments, and most of all, it allows businesses in the beauty and wellness space to manage their business. We want to take all the pain of running a business from them and do it ourselves and let them focus on what they do best, which is performing services. So for the partners, we offer appointment scheduling, point of sale system, payments processing, marketing integrations, inventory, CRM, a lot of stuff that's provided by us. And of course, we built a lot of it in Elixir. So yeah, when it comes to numbers, we have, as you can see, over 80,000 businesses on our platform, 300,000 professionals around the world, and 30 million appointments every month. It's great to be here. It's great to sponsor. open source community, so we just want to give to the community. And I think it's very important events like this keep us connected, keep us stronger as a community. And we also, apart from sponsoring conferences, we also sponsor open source contributions, repositories, and projects. Yeah, so then come over and talk to us. We have some notebooks, some stickers, and some fun staff, fresher staff that you can talk to. Okay, I hope you have a great conference, and I'll talk to you later.
Thank you. For those folks standing in the back, we have almost a whole empty row up here. If you want to come on up, that's okay. You can do it now. Come on, come on. And there's some empty seats over here. And if you have some empty seats in the middle, if people want to move in so they clear the aisles out, that'd be great. So, all right, now we're going to hear from Alexandra Lemos from CoverFlex.
So, hi everyone. Thank you very much for being here today. We are CoverFlex. We provide flexible compensation for modern companies. In a nutshell, this means that we allow companies to have a one-stop solution where they can provide compensation benefits for their employees. And on the employee side, we have flexibility for the employees to choose what they want to invest or to spend their money that the company allows them to have. We are proudly users of Elixir since the beginning of CoverFlex, and we are very proud to sponsor this event today, and we are also really proud to have ElixirConf here in Portugal. So thank you very much, and have a nice conference.
Thank you. Okay, our next sponsor is Judith from Starfish, whom I met in Colorado.
We did. Thanks, Jim. Good morning, everyone. Welcome to the conference. My name is Judith, as Jim already introduced, and I'm one of the co-founders of Starfish. Starfish is a remote-first tech company, and we're specialized in payment and banking solutions that we deliver to our large-scale customers around the globe. As we are remote first, also our teams are distributed all over the place. Like we have 15 countries in the meantime. Does it work? It works perfectly fine. Because we believe in diversity, self-organization, and the power of decentralized organizations. We are building our products, of course, with Elixir. And it's not a secret anymore. We are looking for new members to join our great teams. So if you want to know more about Starfish, how we're using Elixir, or if you just want to get some great swag or solve a little coding riddle, join our booth. It's screaming yellow. You won't miss it. Come by. Have a great day and enjoy the conference.
Thank you, Judith. Our next sponsor is YOLO Group, Rio.
Hello, I am Reijo. I'm a CTO at YOLO. We have been using Elixir actually for over 6 years. We have, I think, 63 attendees today. Maybe 5 of them are remote, but yeah, talk about Coop. So we are fintech and iGaming and also crypto company. It's too much of services to start or products to mention one by one, but I mention one, which is Moon.io. It's a design system that is for designers, and it is also has a component libraries for React and Elixir LiveView surface, more specifically. If you want to learn more about us, come to our booth. there is a game that you can play there. Top 3 will get crypto prices, cash. And there is also other goodies there. Enjoy the conference. Thank you.
Thank you. I sensed a little competition there on the group sponsors levels. I don't know, maybe it's just me. Okay, next, Metan Arslan from PepsiCo.
Hi, hello. It's amazing to be here. Like, it's only 1 hour. We already met a lot of great people, and the energy in the conference is amazing, really. And I think you all know what Pepsi does. We sell the beverages, snacks. But the thing is, you may not know, it's like we are using Elixir like everywhere in our company. Like our e-commerce team, we have more than 250 people. Actually, we are one of the biggest Elixir employers. So another thing is we are very happy to be sponsoring this event because you know we are here thanks to you. I mean, all community, all these repositories that we are using made by some of you. So we want to give back to community. That's why we are always happy to sponsor such amazing events. And we are hiring, so please visit us our booth and we can talk more. Okay, thank you, thank you.
Thank you. And finally, Steve Graham from Teller.
How's it going, Jim? Bom dia. Muito bom dia para vocês que falam português, and good morning to everyone that doesn't speak Portuguese. How you doing? My name's Stevie. I'm the CEO and one of the founders of Teller. My co-founder Dan's here. A bunch of our team are here. We make banking APIs that let you connect your application to users' bank accounts. And we do a lot of cool stuff with Elixir. We've been using it since the beginning, which is quite a few years ago now. We use LiveView since 2019. We use Axon and NX since last year. We even use Nerves. We've been using that for a few years too. And I'm telling you all this because I want you to know that we do a lot of cool, interesting stuff with Elixir. And like everybody else, we're hiring. So if you're interested, we're outside. We've got the big, massive booth by the stairs. We also have a challenge where you can hack the Teller bank and reverse engineer the private API, because that's actually how we get access to the banks. We crack their apps and reverse engineer the private APIs. If you can make the API call to the Teller bank server, you could win a Flipper Zero, which is this cool little hacking device that you can even use to unlock your friend's hotel room doors, which Dan did last night to various people on the team. Cool. We'll be outside if you want to chat to us. Thanks for your time. Hope you have a great conference. Great to be here.
And of course, that hacking is just purely theoretical. It's not really done. Okay, so a little bit of logistics here. Man. So right now you're in Europa, which is track 1. Okay, this is our plenary track. That was interesting. And our track 3, so right out to the right, tomorrow we will have a virtual-only track, and that's track 3. That'll be just right to the hall to the right. All the sponsors and food and beverages will be served in Londres, where you were there this morning. And when you get your food and whatever for lunch and breaks, you can then go to the first floor, two flights up, and you can go to the Galleria, or you can go to the Malau room. And then also on that first floor is the second track, track 2, which is Roma. All right, there will be a test afterwards. Also, since it's so crowded here, by the way, we have about 10 seats up here in front if you guys still want to file in and get seats. We will be streaming these keynotes in Roma. if it's too much for you to come down and sit in the empty seats, you can go up there and sit in the seats. So. Now, I really appreciate, I mean, I have to apologize though. Yes, I think we filled this place to capacity. The interest was huge this year. We're really appreciative of everyone here. And so, you know, thank you for bearing with us as we get through this. It's pretty awesome though to see this many people. Okay, we'd also request that you rate the talks, give some feedback to the speakers. That helps them, and it helps us know what is best for the community. There will be some people with tablets to help you do that. So, and a little treat during lunch: T-shirts. T-shirts get handed out during lunch. So look for that. They look awesome, don't they? Don't those T-shirts look awesome, guys? So yeah. Give a hand for the designer. Lightning talks will be at the end of the day today in this room, and so I'm sorry we're already full apparently, but yeah, looking forward to lightning talks. It's always the funnest part. And have you heard of graphical recording? Oh, so Carlo will be recording the talks graphically as in live, real time, and he'll be posting that on his Twitter channel, which is, where's that at? Is it not on there? Visual Partner. Oh, there it is, Visual Partner. So look for that, and you can watch the talks visually. Okay, so we all know now is the time for, it's a new age, the LLM, the large language models, and the computer's AI, and you know how lazy I am. I asked ChatGPT, I said, hey, I'm hosting this conference, and I got to make this introduction. Can you write one for me, please? So does anyone want me to read this? Okay. I'll try to liven it up a little bit. Ladies and gentlemen, welcome to ElixirConf EU. As we gather here to explore, learn, and celebrate the world of Elixir, it is with great excitement that we welcome our distinguished keynote speaker, the very person who brought this remarkable language to life, Jose Velim. Jose, the creator of Elixir and co-founder of Dashbit, has had an immense impact on the programming landscape. His background in computer science, passion for functional programming, and deep understanding of the Erlang ecosystem culminated in the development of Elixir in 2011. Since then, the language has gained widespread adoption, transforming how we write software. So far, that's all pretty true. Beyond his technical expertise, Jose is committed to nurturing a vibrant, inclusive, and collaborative community that welcomes developers of all levels and backgrounds. His leadership has played a vital role in the growth and success of Elixir. As we begin our journey at ElixirConf EU, let's welcome the driving force behind Elixir, Jose Velim.
Hello. Yes. I think Jim's out of a job as MC host. Although not all that was accurate. All right, let's get this started. How is everyone doing? Hopefully everyone is great. This is our biggest Elixir Conference EU ever. So thanks everybody for coming. And I want to give a huge thank you to the organizers. Woo! So if I look a little bit tired, it's because I live in Poland and I traveled by bus. Yeah, there's an airline called Bus. All right, let's get this started. So last year, my keynote at Elixir Europe was My Future with Elixir. And the idea there was to talk about, to motivate all of us to think, as Elixir was its 10th birthday, to think, what is our own future with Elixir and where we want it to go? And for me in particular, there are three main areas of interest. And those are the areas that I said last year that I was interested in: set theoretic types, developer and learning experience, and machine learning. And last year I talked a lot about set theoretic types. That was the focus of the conversation, more about types in general than set theoretic types, but we talk a lot about typing, why we may want or may not want to have types in Elixir. But today, I want to focus on the developer and learning experience, okay? And, oops. So I want to focus on the developer and learning experience, but I know that many of you are probably very excited to hear about some updates that we may have on the type system front. And Elixir 1.15 is also going to be coming out next month, so you may be interested in knowing what is happening there. So the plan for today is that we're going to talk about Elixir 1.15. We are going to talk about some brief updates on the type system effort, and we're going to then finally talk about the developer and the learning experience. I'm not going to talk about machine learning today, but we are starting to have more and more talks and materials coming up in the community. At the event, I believe we have at least 2 talks from Lars and Jonathan. So if you're interested in the machine learning front, I recommend checking them out. And let's do this. So Elixir 1.15 is going to be our most boring release ever. All right? If you go check the changelog, yeah, right? If you check the changelog, there is not really is only possible because it's a partnership between the CNRS and Remote. So Remote was here on the stage earlier today. Go check their booth. And it's also being sponsored by Fresha, who also has a booth at the event, Supabase, and Dashbit. So I just want to quickly thank them for sponsoring this very important work for the community. Yeah, and then the roadmap, if you're out of the research stage, right, we're just coming out of the research stage, the next step is going to be development, right? We're going to start finally integrating some, the set theoretic type system into the Elixir compiler. So that's going to start in the second semester of this year. We'll initially focus on patterns and guards, and we are looking for sponsors. So we are very thankful for the sponsors that helped in the research stage. Now we are starting this new stage, and if you are a company who is interested in sponsoring this work, please reach out to me. That's it. I won't talk about type systems today. Go check the Guillaume's talk, or if you're not familiar with the topic, you can check my presentation from last year. Now it's time to talk about the developer and learning experience. So focusing on the developer experience is nothing new for Elixir. We have focused on this since the beginning. That's why we have tools like Mix, Xdoc for generating documentation, Hex, right? But as Elixir has become stable, we have been able to put more and more energy towards let's say we're putting more cherries on the cake, all right? So for example, the recent release we added DBG. Yes, it's sprint-based debugging, but it's pretty awesome at it. It improves the workflow a lot when you want to inspect a pipeline or when we have to see what multiple parts of the code is doing. We added mix install. So mix install, Elixir before, if you wanted to try a dependency, you had to create a mix project, list the dependency, and then start playing with it. With mix install, you can just like in IX or in a notebook, you can immediately install a dependency and play with it and see what it is about. We have worked with mix format plugins. So we have the formatter for probably, 6, 7 years. And we added this idea where you can have plugins in the formatter. So now if you're working on a Phoenix application, with the same command, you can format all of your Elixir code and all of your markup too. And that's pretty awesome. I use this all the time, and I really love it. Don't have to worry about like formatting the code manually. Doesn't matter if it's HTML, it's Elixir, whatever. And we also worked on low-level tools like compilation tracers. So if you're building, for example, like a language server, or if you're trying to make something that really tries to understand how the Elixir compiler works, we've added these compilation tracers, which allows you to hook into the compiler, learn more about it. And we also worked on this thing called code fragment, okay? And the challenge with working, for example, let's imagine we want to improve the IDE experience. So the Elixir compiler, it's like, if you forget to close a tuple, we'll be like, I can't compile that. Like, you didn't close that tuple. Please go and close it for me, right? So we work with complete code. Like, the code needs to be complete, needs to be valid. But an IDE is not like that, right? Like, you open a tuple, you start typing, maybe the code doesn't make sense, but you want to get suggestions about what are the variables, the functions, right? So an IDE needs to deal with fragments of code, hence code fragment. And we have been working on these ideas within Elixir itself. We're starting to bring more concerns that an IDE would have, and they would try to understand about Elixir code. We are trying to bring it to Elixir to make the lives of everybody who is working on those tools easier. And we use this now in IX, in the Elixir language server, in Livebook. And Dashbit has hired Łukasz Samson to work part-time on improving the language server and the tools that use it. Something else that I'm really proud of the community that we achieved. So GitHub has this feature called code navigation, and you can see that code navigation was enabled for Elixir. Probably, they don't have a date here, but I think it has been more than a year. And this was really cool because before, if a language had code navigation on GitHub, which means like you can go click on the modules, or you can click a function and see where it's defined and other places that use it. All the languages that were supported before were languages where GitHub went and implemented the features themselves, like the GitHub team. But the Elixir community was able to stand up and implement everything that was necessary to bring code navigation for Elixir. And then we reached out to the GitHub folks, and they incorporated that. And GitHub did a blog post saying, now we have code navigation for communities, and Elixir was the first language that has paved the way for other languages to do the same. And I could go on and on and on and talking about like developer experience and learning experience, but how can we talk about developer experience if you're not going to be coding, right? So that's what I want to do. I'm going to use, if it all works out, I want to use the rest of the event to do some live coding and just show some ideas, some things I'm excited about. All right, so who here has used Livebook? Nice, really nice. So Livebook it brings computational notebooks to Elixir. It's very easy to install. You have like an installer. You just go double click and you have it running on Mac and Windows. So we have a desktop application. That's a better way of saying it. And Wojtek is going to be giving a talk on that today as well. So, and the idea about, well, I'm going to show you, right? So here I have Livebook running on my machine. Let's see if I can make this full screen. Yeah, I have Livebook running on my machine, and I think Livebook is going to continue playing a very important role in making Elixir more accessible, and also, not only from the learning experience point of view, but also about allowing the community to grow and learn about new tools, right? So I have Livebook running on my machine, and I prepared this notebook for today's presentation, and that's how it looks like. So we have some notebook here, and a notebook is a place where you can basically mix code and documentation and prose, right? So here, the first thing that we do is a mix install. I have a bunch of dependencies that I have to install for this notebook. And I ran this before, so everything is cached. And now I can start playing with some code. So for example, imagine that we want to teach somebody about Elixir. At some point, we are going to talk about processes, right? Because processes are a very important thing, very important abstraction for Elixir. So we probably say, hey, you can create 1 million of processes. Well, is that true? We can just click here. By the way, in the back, is the font size good? Can you? Perfect. There in the corner, good? Fantastic. Right, so you can say, hey, you can create 1 million of processes. And yeah, we can literally do that. I can go, I can create 1 million of processes. I can come here and say, yeah, it took 2 seconds. It's meant to be faster, but yeah, it's going to be 2.5 seconds. And yeah, you can create 1 million of them, and it's going to be super, super fast. Right? And then later on, I'm going to say, oh, and those processes, they are all concurrent and isolated. And they are running at the same time. Like, so people have to start imagining those things, right? Like, oh, they're all running at the same time, right? And then you can say, look, and when they have to do something, they have to exchange messages, like they can send messages to each other. And then you can write this code. You can say, look, I'm going to spawn a child process, and what this process is going to do is that it's going to receive a message. It's going to receive a ping message with a caller, and it's going to send pong to the caller. So we spawn this process, and we store it in the child variable, okay? So that's good. And then we send the ping message to this child variable, and we are expected to receive a pong message. And if all this works, right, we are going to see it worked as a result. So we can execute the cell, and then it's like, oh, it's great, another code sample. But because we are now in a rich medium, we are not like in the terminal anymore, we're not in IX. Because we have a rich medium now as a browser, we can say, wait. So if I get the same code that is here, the same code, and I wrap it in a function called render_sec_trace, now we get this. We get a diagram showing exactly what is happening, right? So we don't have to imagine anymore. We can start showing things, right? It's like, oh, okay, I have a process which is self, is the current process, and we can see that it spawns that other process, and it sends a ping message, and it gets a pong message back, right? And it's not only about learning. So who here has used task async stream before to do concurrent parallel work, right? Great. Do you know how it works? What it's doing behind the scenes? Well, let's just call task async stream here. It's going to sleep for a random amount of time, right? And let's ask it to render the sequential trace. Okay? And now we can see, look, we have the current process. Let me increase this a little bit. We have the current process, right? And then you can see we expect at least 4 other processes, right? Because I said, look, we are running things concurrently, and the concurrency is of 4, the number 4. And then we can see here, okay, and they are sleeping for a random amount. So you can see like this one started, and then it finished here. The last one seems to be the shortest one. It started and then finished very quick. We can start getting an idea, right, of how it would work if we're doing something concurrent, either CPU or I/O based. But as I said, we're expecting to have how many processes here? The current process, right, and then 4 others. But we have 6 processes here. We don't have 5, we have 6. So you can say, oh, I can see. It seems that Elixir is starting a coordinator process that is responsible for starting all the other tasks concurrently, and so on. So we can start like playing with those ideas and build an intuition of how things work. And that's why I think it's bringing Elixir to life, because now we're starting to visualize and get more information from our system in a much more accessible way than we ever did before. So, and we can show all kinds of things just with Livebook, right? And because it's a desktop app, just installing it is also very easy, right? So we also say, hey, now we have processes, and processes, they exchange messages. But the cool thing about that in Elixir, thanks to Erlang, is that we also get distribution because of it, right? We can also talk to different machines. So let's see an example, right? So I'm going to say, look, let's try to call distributed hello world, okay? We are trying to call the module distributed and the function hello world in it. Well, it doesn't exist. We get an error, right? But what if the module distributed is defined on another notebook, which, as we are going to see, is defined on another instance, right? Which could be on another machine. So I can go to this other notebook. And what I'm going to do here is that I'm going to, very simple notebook. It defines a module, and then it prints the node name and the cookie for that node, how we're going to access that node. Right? So I can go back to this notebook, and I'm going to use Livebook to render inputs for us. So I'm not going into details over the code, but we have this Kino thing. We're going to talk about it soon. That allows us to define inputs. So we can define 2 inputs, one for the node, one for the cookie. And then we set the cookie for that node so we can call that module that we defined in the other notebook. So we can do the distributed communication. So I can come back here. I'm going to copy the node name. I'm going to copy the cookie. And now we are invoking the module from the other notebook. So hello world from another notebook, right? And then boom, we just show an example of distribution. We didn't have to feed with flags in the terminal in order to make that work, right? And we can go on and on. Maybe you want to teach somebody about a supervisor. So if you're using Mix, right, it has a supervisor called mix.supervisor. If I just have the name here, it says, yeah, that's an atom, right? That's Mix supervisor. But it detected that it is a supervisor behind, so I can just click here and see the supervision tree. That's how easy you can access the supervision tree now for anything. Or maybe we have Mix, right? This is an atom in Elixir, Mix. But we also know that it is an application. So if I want to see more information about this application, I just click here and I can see supervision tree, and we may add more things in the future. Right? So that's the idea, exploring what we need to do, everything's just more accessible. And the other cool thing about this is that we have been talking about processes, right? And it turns out that processes and distribution, the things that I have just been talking right now, is how Livebook works behind the scenes as well. So let's learn about that, right? Since you're here, let's continue learning. So one of the cool things about Livebook is that we can build collaborative things, and I'm going to build the intuition of how we can do that, okay? So the way it works is that, so one of the things that we have in Livebook is that we can have diagrams with Mermaid. So the way it works is that Livebook, which is the web application, is running Elixir, right, on one process of the operating system, right? And then each notebook, they have a runtime, which is another process of the operating system. Right? So there are 2 different operating system processes, and then they communicate through the Erlang distribution. That's why when we did the distributed notebooks, right, it's like we had 2 different Erlang instances, Elixir instances communicating directly with each other over the distribution. And this is interesting because it brings the separation of concern where the code that you are running, the code inside the notebook, actually knows very little about Livebook. It knows almost nothing about Livebook. And in order to bridge this gap, we have this library called Kino, which I've mentioned a little bit. We're going to go back to it. We have this library called Kino that runs with your code, runs inside the notebook in order to teach it about Livebook things. Right? So for example, let me give an example here. So when we talk about Kino, every time we have like this kind of rich visualization here, like those tabs, we see those graphs being plotted. Those are always, or the inputs, those are all features contributed by Kino. And most of the things that we have seen so far, right, they have been static. Like, yeah, we got the diagram, but we can't really interact with it. But the cool thing about Kino is that it has 2 kinds of outputs. So when you have a cell, the cell can output 2 kinds of things, the static things that we have seen so far, like an atom, right? It's just like the result. But we can also create live outputs that we can like interact with it and broadcast information. So for example, let's do a counter, a very simple example. We're going to create a bidirectional counter. I'm not going to go through the code. We have this in our documentation. But these 50 lines of code, right? And then we have to render the HTML of the, well, let me evaluate the cell. So basically what we're doing is that we are creating a counter, 50 lines of code, not going to go over the details. But we can see here that we get a counter at the end. And then we can just go and bump it. And the cool thing is that if I start another session as another user, I could go into incognito mode, right? And then I come back to the same counter somewhere. Yes, right? You can see that, you know, it's collaborative, right? So not only Livebook in itself is collaborative, you allow like multiple users can like write a notebook together. It allows you to build collaborative applications too. Last week we did an announcement where we created a chat app using Livebook and machine learning, where you would say a message to the chat app and it would send to everybody. I'm going to show an example about this soon, right? So the idea here is that we have been like using it to debug our system, but we are only scratching the surface, because the way that we have debugging things so far, they're always static, but we can make everything now interactive if we want to. And the way it works is that if we build a little bit more in our architecture, is that each client, the browser, connects to Livebook using WebSocket. So everything's powered by Phoenix. It's using Phoenix Live View. And so the WebSockets connect to the Livebook server. And then your code is running in a process. But each rich output that we see, like the counter, it's running on a process as well. So your notebook, in reality, it's all those processes that are interacting with the page, right? And we can build this cool stuff. So for example, let's see more stuff, right? So one of the cool things about the Erlang Virtual Machine is that it has a lot of great tools for observability, right? So we can list all the processes in the system, and then I want to get some information like how much work they have done, which is called reductions, their memory usage and status. And then we get this, right? We have a list of maps. Cool, we can work with this. But since we are in Livebook, what if we just put this on a table, right? And now we get a table with all the information, and we can go, if we want, we can sort it. We can say, oh, what is the thing that is using the most memory? We just come, we sort it, and we start having an idea and start interacting with the data, right? So there are a bunch of more examples that we can do about it. But in the interest of time, I want to move to the next topic of Livebook, which is smart cells. Has anybody used a smart cell before? All right. So, wait, this is a spoiler. This is not supposed to be here. Hold on. All right. So everything so far is like really nice, I hope you're enjoying it. But ultimately, right, we are still learning new APIs for everything. Yeah, you want to plot a table, you have to know that this Keynote data table exists. Oh, you want to do an input, you have to know that Keynote input exists. And you're hearing like, yeah, we can do machine learning stuff in Elixir, but you have to learn the libraries, right? You have to learn, you have to go through the documentation, go through the tutorials in order for you to get your first thing running, right? So yes, it's a brand new world. There's a bunch of exciting things, but there's also a bunch of learning. What if we could speed up this process, right? So for example, we have this information about processes here, right? Like we have the memory, the reductions. Well, what if we could, and imagine that now we want to plot it in a graph, right? Livebook can plot stuff, and now somebody says, hey, can we plot this? I'm like, yeah, we can plot it. And I would have to go and learn a new library. But with Livebook, we have the smart cell, so I can say, well, what I want to do is that I want to plot a chart, and I want to plot, so the data, it already picked up that the data comes from the process variable because that's the only plottable data that we have. So then we can say, okay, I want to plot the memory by the reductions. And I want to use the status as the caller for the process. So I just choose that, and then it started plotting some information. Right, but it's not very helpful here because we have a process that's using a lot of reductions, a lot of memory, so all the processes here at the bottom, we cannot really distinguish them. So maybe we can come and change the scale a little bit to something like a log scale instead of being linear. And let's change here as well to the log scale. And now we're starting to look more and more at the data. We can increase the width here, and now we start to see some information about our system, right? Like, yeah, there is one process that is running, doing a lot of the work, and we have a lot of processes that are doing a lot of work and using a lot of memory. And again, we start building more and more intuitions about what is happening in our system. And the cool thing, and this is nice, right? But the cool thing about smart cells, like, well, imagine that you want to do something more with this chart, and it's something that we don't have an option here. You want to further customize it, you want to further extend it, but such an option does not exist. What can we do? The cool thing about smart cells is that all they do at the end of the day is that they tell the notebook to execute code. That's all they do, right? And we can actually see the code that they are executing. That's it. That's the plotting library that we use. It's all here, which means that now if you say, hey, I want to customize this chart somehow, right? I can just convert this smart cell to a code cell, and I can go and change it like an Elixir code, right? And kind of start manipulating with it. And, I didn't say this, but Livebook functions like an IDE. You can get documentation for modules here just in place. You can get auto-completion, if I remember what is the shortcut. Well, let me do another example. Right, so if you're doing enum, and then you type something, you get auto-completion. You get the full IDE experience, right into Livebook. And now you know, you plotted your first graph, and then if you want to do something more complex, you already have a starting point. And from here, you can start learning more about the library, right? But it's not only about plotting graphs. So we have this new library in Elixir called Explorer, which is about data exploration. Right? So you work with really large amounts of data, like gigabytes of data. So, well, imagine you want to do that. You can add a data transform smart cell, right? And here it's saying, hey, I don't have a variable that I can work with. It gives an example for us to work with, so let's define that variable. Here, yeah, so it has some sample data for us to play with. And now here, I can just say, well, okay, yeah, I want to, so the iris data set is a very known data set that has information about flowers, but we can start playing with this idea here once again. Say, okay, I want to get where the length is more than 0. It's a silly example, right? The length is always going to be more than 0 for a flower, but we can go, we can run it, we can start filtering the data, we can group information, so we can say, well, let's say I want to group by the species, because we have different species of flowers in the data set, and I want to summarize this data by getting the mean of the length and the width, right? So you can start playing with the data, right, and starting getting information that you can do whatever you want later. You can plot it, whatever you want to do. And once again, you're saying, okay, I got started, but now I have to use this library in my actual application, right? And then you can get the source code, and you can learn how to use the library and how to write those queries, right? Last example I'm going to show about smart cells is machine learning. So yeah, Elixir can do machine learning stuff now, really cool, but how are you going to get started? Neural network task, boom, and then there are a bunch of tasks that we can do, all those tasks, and I want to do something like speech to text. So I just configure which model that I want to do, and I evaluate, and what this is going to do, I hope, I hope it's not downloading the data set, because that's going to take a while. Oh, I did something wrong here. Oh, yeah, good point. So let's solve this problem by removing the cell. Something got stuck. And now it has to, we kill the runtime because that cell got stuck, and now it has to evaluate everything again. But wait, something is going horribly wrong, because now it's not installing the dependencies either. Hold on, let me, yep, we are back. All right, I'm going to just evaluate the cells very quickly. This is going to break. This. All right, so now you're good. All right, so let's say, okay, we want to do a machine learning model, right? So you can choose, yeah, speech to text. You can choose that as an example, right? And then what it's going to do is that it's going to set up both the machine learning model and the form for you to interact with the machine learning model, right? So I can come here and I can say, hold on. Hello, darkness, my old friend. And I put the audio, I submit it, and the first time it's going to compile the module, it's going to do everything that's necessary. Well, my accent screwed that up a little bit, but yeah. Hello, darkness, my old friend. Yes! Right, and once again, you want to check out the code, you can check out the code, right? And we have examples of getting the code from a machine learning model, putting that into a Phoenix application, and running that in production, right? So that's really cool, really nice. And again, everything is just processes, right? So we have the browser, it connects to WebSockets to the Livebook server, and your code that is running the notebook is a process. The Smart Cell is a process. All the outputs, they are processed as well, and that's why we can be interacting with all those things at the same time. So, all right, before I finish this talk, there is one last thing that I want to talk about, something that we have started exploring, but we have not yet achieved the full potential behind those ideas, which is the idea of leveraging Livebook more and more for live programming, right? So who here has used DBG before for the new debug stuff? Has anybody used DBG in Livebook yet? All right. So for example, DBG allows you to print like the result of a pipeline instead of the steps of a pipeline. So when you do that in the terminal, it prints the result of each step. And it does the same in Livebook. But again, because Livebook is a rich medium, what does it mean to print a pipeline in Livebook? This is what it means. It prints the pipeline, and you can actually go and change the order of the operations to see how that affects the pipeline, right? So you can turn things on and off to see how and every time you can see how the result changes, right? Every time you are doing this, right? And then you change the order, and you're like, oh, maybe there is a bug because I figure out that if I put Elixir, like maybe we want to get the first word without bang, and then it's like, okay, how are we going to change things in order to get these results? We can explore with all those ideas, right? And then after you change the pipeline, maybe you get a solution that you're happy with. You can copy the new pipeline, and you can put it in place. And now, boom, you have your updated code. Is this going to work? Well, yeah, the code at the end is wrong, but the idea is sound. Right, the other thing that we can do, and this is an example from Ryo Wakabayashi, who is also giving a talk at the event, which is like, well, we can also work, again, it's all about rich visualization, so we can also work with images. So we can download this image from the internet, right? And then you can say, well, I have this pipeline using OpenCV that is manipulating the image, right? And this is the image that we get at the end. And then you're like, wait, no, this is not quite right. So once again, we can come back here, right? And start changing the pipeline. Well, let's remove the blur, right? Oh, okay, that's better. Maybe I want to rotate after I put the ellipse, and that's closer to the dog. So you can go and start playing with those ideas, right? All through the pipeline, and it works with any kind of rich media. If you have like a table where you're processing a bunch of things and you wanted to study the process, like the operations in the middle, you can do all of that, right? And the last thing, so when I said that there's still a lot to explore, right? So DBG is really cool, but one of the things that we in the Elixir community, we're very proud of documentation, of writing documentation, right? Really good documentation. And if we're using Livebook to teach somebody about Elixir, it would be nice if we were telling them like, hey, write documentation to your functions, right? That would be fantastic. And then we can write documentation to the functions and you can access them in Livebook, which is really cool. But we also focus a lot on tests. And one of the features that we like a lot are doc tests. So we can write examples in our documentation and to show how to use our APIs and verify that the examples are valid. Well, if we have Livebook, what could we do, for example, if we could, every time, it could automatically detect that they are doc tests and run them for us from every cell? And that's exactly what is happening here, right? So we just started exploring this idea. You can see here that the output is just printed to the terminal, but there are so many things that we can do. We can like show in status here now, close to each doc test, saying, oh, it's green or red, have ways of putting the result close to the code. And that's what I wanted to talk about today, right? That's what I want to show. It's like now having this rich medium, it allows us to explore ideas in different ways. And we are just beginning. And the cool thing that those things are going to trickle down, right? So when we start adding those tools to Livebook, for example, they can be incorporated into IDEs. And I think that's very exciting because before, when I was working on Elixir, I would always think, well, people are going to use Elixir from like an IDE or from a terminal, right? I did not think about this rich medium where we can interact with outputs. And I'm constantly thinking about this, like, well, we have this feature. And if we use it in Livebook, how that's going to look like. So yeah, that's what I wanted to share for today, those ideas about bringing Elixir to life. I hope you have enjoyed, and I hope you're going to have a great conference. Thank you. Yeah, we can. If we have time, we can do, yeah.
Wow, great. I think the chat introduction undersold that, so that was great. We have some time for questions. Does anyone have some questions for all this? No? No questions for Jose?
Yes, there's one there.
Well, great talk. Thanks a lot, Jose. So maybe a newbie question. So there is Jupyter, right? Jupyter Notebook.
Yeah.
And I'm just wondering, why did you decide to, introduce a new one? Why not to extend that one?
Yeah, so the question is about Jupyter Notebooks and why we decided to create a new one. So, okay, I'm thinking. All right, we're going to go with long answer. So, so there are a couple reasons. So one is like Elixir has been really good. So one is like scratching our own itch kind of thing. Like we want to build something like that because we have a really nice platform for building web applications, and there's live view. So we wanted to build something really complex with live view to show that it works, that it's scale for complex apps. So there was that part of scratching our own itch. But the other thing is that I actually wrote this for the presentation, and I removed it in the interest of time. But with Jupyter, the way that Jupyter Notebooks, who here has used Jupyter Notebooks? All right, amazing, yeah. So Jupyter Notebooks, they started with Python, but you can have runtime for other languages. But the way that Jupyter Notebooks work is that you can think that you have some global state. And every time you execute a cell, you are getting that state, doing some operation on it, and putting it back, right? So for example, I'm going to show some examples here. Right, so imagine that you have this, right, x equals 1. So if you think of in Jupyter Notebook, that would like set the variable there in some state. And then if you say like x equals x plus 1, you want to increment it, it's 2. But in the Jupyter Notebook, if I executed the cell again, every time I executed it, the value would increase. Because it's global state, the cells are basically like getting things from that state, changing it, and putting it back. And the things that we don't like global state, right, that make things hard to represent and to understand, to the point that people say one of the biggest issues with notebooks in Jupyter is reproducibility, right? Because if you imagine that every time I execute this cell, this value change, how am I going to share that notebook with somebody else? I'm going to say, hey, execute all the cells, but when you get to cell 4, remember to execute it twice, right? It's not very helpful. So this was also a good opportunity to like think from scratch about some of the problems that they are there. And now that we are in a functional programming language where things are immutable by default, like maybe we can have new solutions to this problem. So, for example, and the thing is that in the Python community, there are attempts at solving this problem, but because everything is mutable, like if you mutate an object, that is a state in your notebook, and that's going to be there. There's no way you can work around it. So in Elixir, the way that Livebook works is that the whole evaluation is sequential. You execute everything from top to bottom. There is no out-of-order execution. But because because everything is immutable by default, we can do like cool things, like co-analyze. So for example, imagine that I have x equals 1, y equals 2, and now I define a new cell here that is the result of x plus y, right? So one of the things that we can do, for example, is that we can analyze the state and the dependency between the cells. So for example, I have x equals 1, y equals 2, and I change this cell here, and I evaluate it. So we know that the value of x changed, but we can see this, and then we can see that x plus y, now it's stale. It's telling us, like, hey, you know, you change something that this cell depends on, so you may want to reevaluate that. But y equals 2, we know that that thing doesn't depend on x. So we know that that thing is not stale. So this is a great opportunity to you know, like, to think about some of the problems and have a tool that is more tailored for us. And like some people have asked, like, are we planning to bring this to other languages? And I think the truth is that Livebook is really useful for functional languages. I think the general imperative language is not going to be that useful because a lot of our infrastructure is built around the fact that, yeah, we can understand the language and we know that things are immutable by default, so we can leverage all those types of properties. Yeah, thank you. There are probably other reasons, like smart cells. It's something like that it's also very specific to how Livebook works and so on. So there are other reasons, but I think those are the main ones. Thank you for the question, really great.
Hey, good morning. Thank you very much for the talk. I have a question about Livebook and the neural networks. And I have a little problem still to wrap my head around how to deploy something like this to production. So where would I run my neural network? And I wanted to ask, is there maybe something coming up in, like, to show how you can really bring this to production and use it in production as well?
Yeah, so it's a great question. There are many options of how you can do this. And I think one of the exciting things about machine learning in Elixir is that when it comes to deployment, you have all those options available that you don't have in the other languages and platforms. So I published a video last week called Distributed Square Machine Learning with Elixir. And the idea is that with Elixir, so for example, let's think a little bit about like Python, for example. Like with Elixir, with Python, you could run the machine learning. For example, you have a web app, it does machine learning stuff. You can run the machine learning model within your Python process, for example. But usually when you are deploying a Python system, you are starting, like if you have a machine with 8 cores, you are starting like 8 instances of this machine, right? So you don't want to start like 8 ML instances, one for each process, right? So usually your option when you're like, hey, I want to do ML in production, your option is, yeah, you're going to put that ML model on a separate server. Maybe you're going to pay somebody to host that AI model for you, which is a very sensible option. It's something that we can do in Elixir, but your options are usually around there. But in Elixir, because if you have a machine with 8 or 20 cores, you can actually just have that and have the model collocated with your Phoenix app and just run those things together. So that's one option that you can do. And it's all going to depend. It depends on many factors. It depends on the model size. Because if you have like a really large model, you're probably going to need GPUs for that. So you have to, there is a cost equation on that. Like, do you want to have things on the same server or different? So you have to consider, but you have the option. You can run on that same machine, regardless if you have GPU or not. But you can also run on a complete separate server. But the things that we added with NX now is that I think you have to change 2 lines of code or something like that. You can have a model running anywhere in your Erlang cluster. So what that means, for example, is that Fly, if they support GPUs, for example, what you could do is that you could deploy your Phoenix application on Fly, and then you have like Phoenix instances in different places around the globe, and then you have 3 machines with GPUs in there. They're all connected in your Erlang cluster, and it's just going to work. All you have to do is like change 2 lines of code or something like that. So the idea is, I don't think there is an answer. It's going to depend on the model size, your problem, what is your flux, and I think we're going to, your flux of requests, and I think we're also going to learn more as the community starts to really use it and deploy those things. But I think the good news is that we have a lot of options that we want to consider. So for example, like running in the same machine, it's very important for nerves, right? Because in nerves, if you want to run like machine learning on the device, that's your option. You have to run everything together. And we can explore all of those possibilities and combinations. Thank you.
I think we have time for one more question. All right. Well, let's give Jose a big hand.
saw you, I got excited. Tried to keep my composure, trying to hide it, but I didn't know. I didn't let go. Then I realized I'm trying to fight it. Just surrender, learn to ride it, but I didn't know. Oh, I had to let it go. Like a gust of wind, you hit me off sometimes. Like a gust of wind, you push me back once in a while. Like a gust of wind, yeah. What a man. Shazam, the air with me to power myself. Well, I open the window, I wanna hug you, 'cause you remind me of the air. I said, yeah, 'cause when I'm feeling real low, I remember I love you. I put my hands in the air, and you were there.
And I know she'll be the death of me, at least we'll both be numb. And she'll always get the best of me, the worst is yet to come. But at least we'll both be beautiful and stay forever young. This I know, this I know. She told me don't worry about it. She told me don't worry no more. We both know we can't go without it. She told me you'll never be alone. I can feel my face when I'm with you, but I love it, but I love it. Oh, I can feel my face when I'm with you,
Can I try? One, two, yeah. Okay. Hey everyone. So yeah, welcome again. Thank you all for joining. So my name is Daniel Caixinha, and I'm super thrilled to be having ElixirConf in my hometown. So yeah, it's great to see the community growing year after year, and yeah, this room is huge, and yeah, but we still keep the same level of excitement and engagement. So yeah, it's really great to be here. And so yeah, now I have the pleasure of introducing Simon and Federico with their talk, a domain-specific language for impact. Simon is the CTO and co-founder of Turn.io, which is a public benefit corporation focused on positive social impact. And Simon, and Federico is a software engineer at Turn.io with a strong interest in machine learning and research in general. Simon has already given talks about their work with the WHO on previous editions of the ElixirConf. And now they will share their work on allowing social impact organizations to amplify their work and have an even greater impact. We all know the power of DSLs in the Elixir community, like if you just look at Ecto and its power of DSL and what it allows us to do. And now we'll be seeing DSLs applied to positive social impact. So yeah, please join me in welcoming Simon and Federico to the stage.
Thank you for having us, and thanks for that intro. Cool, let me just see if this all works. All right, so how many of you use chat on your phone? How many of you are in a chat group for this conference with your colleagues? Right, cool. So we think chat is one of the most effective and accessible means of communication that we have in the world today. And so at Turn, we make secure, private, and effective support accessible to vulnerable people everywhere, and we focus on chat as a medium to do that. So our SaaS product makes it easy for social impact organizations to run their chat support services and launch their applications. So we support over 200, some of the world's leading social impact organizations on the platform, including the WHO, which you mentioned, the UN Refugee Agency, and also the State Emergency Services of Ukraine. Now, the reality is that we are all in a very nice hotel here. Hope you all enjoyed the breakfast. I like the tiny coffee cups. They make me feel very European. It packed a good punch. The reality is that half of the world lacks access to essential health services. And so while that may feel or seem like a point of despair, we see it both. It is something that needs to be addressed, but it's also an incredible opportunity. And this is from the research from the WHO from 2017, so it's actually been known for quite some time. Now, again, we believe that chat is one of the most accessible access communication means that we have available to us at the moment. And we know that there's lots of proven health interventions that really work. And there are more than 3 billion people living in low and middle income countries. Sorry, many of you are not in the development sector. LMICs is low and middle income countries. And so there are more than 3 billion people living in these countries that do not have access to health, but we know that there are proven interventions that work over chat that should be available to them. And we think that chat is one of the greatest means to provide accessible, affordable, and effective health support for everyone. And so that is what we are about. And so I've spoken before about us being inspired about Brett Victor. Who knows Brett Victor's work? Some of the designing on principle, those talks are really amazing and inspiring. And so to paraphrase what he says is that creators need direct feedback from the system that they are creating. And I think we're seeing all the power of this. And I was slightly terrified of going up speaking after Jose, thinking like, oh my goodness, this is a high bar. To be honest, it still feels that way. So, but I think we're seeing the power of this idea in the community. These live books, being able to interact with them, to understand the problem that you're trying to solve, have immediate feedback. I mean, those demos of being able to see your supervision tree, It's incredible. I mean, I've got almost 2 decades of programming under my belt, and it still blows my mind just to be able to see it. Like, once you can see it, you understand how it works. So many things were invented really because people didn't realize that it was supposed to be difficult. There was no barrier to them. It was just like, oh, I see it, I understand it, I can do things with this. And so we were really convinced that in this space, we need low floors and high ceilings. And so systems that are easy to get started with, but do not get in your way when you're building out the more advanced things. And so the reality is that many of the world's largest problems, and many problems in software as well, like the hard part is not writing the code. The hard problem is understanding the actual problem and coming up with a solution to it. And so we're about building a system that takes the friction out of finding these solutions and helping these organizations that we work with find the solutions that really address some of the world's largest and most pressing problems. So we've been working at this problem for about 12 years now. We've been searching for the best metaphors that help us describe the kinds of solutions that we believe have a chance of having long-lasting social impact. And so the best metaphor that we've come up with is the concept of a simple card. Stacks of cards on a table. Every stack is a defined piece of functionality, and cards have both content and behavior things assigned to them. And so you can think in the world of chat, you can think about these things like sending a text message, asking a question and expecting a response, sending media, video, audio, that type of stuff. And just, multiple choice questions, quick reply buttons, all that kind of stuff. Again, the hard part is not the code. The hard part is understanding what is the solution you're trying to build, what is the problem you're trying to address, what is the adequate solution for that. And then once you understand that, just using the tools you have to kind of put that together. So the hard part really is finding the solution that's actually worth a damn. And so we built a system around a DSL to help organizations do this. And Federico is going to be talking a little bit more about that, and then I'll be back.
Thank you. Thank you, Simon. So we have this mental model of a stack of cards that defines a chat service. And we wanted to give our users on our platform a way to create this stack of cards. And we decided to give them the option to write them as code. But instead of having normal users who are not programmers actually learn a general purpose programming language, we decided to define a very small and easy to learn DSL, domain specific language. We call it the stacks DSL, that allows you to declare a stack. You can see the mental model on the left, and then it's really easy to translate that into code using this language. And as Simon said, we always want to give immediate feedback to our users and a way for them to test what they are building. So we have a simulator on the right that simulates what an end user would see interacting with the chat service that you're actually defining at the very moment in code. Okay. What about users who don't want to code at all, even if the DSL is easy enough? We came up also with a visual representation of a stack that you can build dragging and dropping cards on a canvas. Still, you have the simulator on the right so that you can test what you're doing. But how do we represent a stack actually internally? How do we store that in the database, right? So we use Elixir, we use Phoenix, we use Ecto. It would sure be nice to have a struct that we can just store in the database. But how do you go from a DSL or a Canvas visual UI to a struct in Elixir that you can just store in Postgres, right? If you're a bit like me, you're thinking, oh no, I need to write a parser for that. It's a huge work. But actually, if you look at our DSL a bit closer, you will see that it shares a lot of syntax with Elixir itself, right? And that's very intentional, because we can use Elixir's own code functions to translate that into a data structure for us. So if you look at the DSL, we actually just need one function call, code string to quoted from the Elixir library, and we get back the quoted representation of that code, an abstract syntax tree, right? It's a kind of complicated data structure, but it's a data structure, right? So at that point, it's just a matter of writing some code that transforms that data structure into the one we actually want. The real magic is that you can also go the opposite direction, and this actually blew me away. So you have a stack struct in Elixir. You can convert that into an Elixir abstract syntax tree, and at that point, one function call, again, macro to string, and you go back to code. And it doesn't end that. You can use the Elixir formatter, another function call, and you go back to formatted code. So that's really special, I think. What about the case in which users actually use the visual drag and drop UI? That's much easier. You don't need any parsing, anything like that. It's already a JSON structure in our React Flow library, so we just need to transform that into a struct. So I'm gonna quickly skip over this one. Cool, so we find a way to go from code, DSL, to an Elixir struct, or in the case of the visual canvas, to that visual format to an Elixir struct that we can store. But what do we do with that? It's not a chat service, it doesn't run, it doesn't respond to users writing to you on WhatsApp. It's just a data structure, right? So it doesn't end there. We didn't want to reinvent the wheel in this case. So we started looking for open standards that were already there that could help us in this case. And the most common one is the Flow interoperability standard that allows you to define conversation flows, actually in form of flows that are composed by blocks, and you can jump from one block to the next one. So this is really similar to our analogy of stacks composed of cards. In this case, our flows composed of blocks. But you can already tell it's just a matter of data transformation again, right? We can go from our internal stack representation to a Flow interoperability JSON compliant format. It's just a matter of transforming data. And at that point, you can run this chat service defined in Flow compliant JSON on any software that is compatible with Flow formats. So it doesn't have to be Turn, it doesn't have to be our platform. We don't want to lock in anybody in our platform. You can actually self-host a Flow runner yourself. There's a few open source packages, even one written in Elixir by us. And you can bring your chat service wherever you need. So just to conclude this part of the presentation, I think what's really interesting is that we went full circle in a way, because you can define a stack either by writing code in this DSL language that we have in our platform, or you can build it visually. It doesn't matter, because we have a way to convert that into an internal representation, a simple struct. So you can go to code, to visual canvas to code, and that can finally be compiled down to Floyd JSON that can be run on any Floyd software. And that way you can power your chat service easily, and we're not logging in anybody with custom formats. Simon, do you want to explain the specifics, because this was very high level.
Cool. So the Flow interoperability standard is largely, sorry, I need to stand in front of the microphone. The Flow interoperability standard is largely just a JSON specification for a state machine. So flows are, like Federico said, flows are collections of blocks, and the tests for the transitions between those blocks, like how do you know how to transition from A to B to go do something, are described using expressions. And I don't know if you can see it. Can you see it okay in the back? Yeah, so it's the things highlighted in pink where it says test and then contact.patient age larger than 18 or less than 18 or larger or equal to 18. So what we're looking at here is a excuse me, is a JSON block for a case statement with 3 exits. So the first exit is for the code path when contact's age is less than 18. The second one is for greater than 18 or equal to, and the last one is the default exit, which in this case is not really necessary because everyone's going to fall into one of the 2 buckets, but I'm just giving you the idea of how this interoperability standard works. For us, this is important. We want the best ideas to be able to be surfaced on turn, this concept of low floors and high ceilings. And if those really great concepts that have long-lasting social impact, we want those to have a lasting impact outside of the things that we control. And so this is why we've committed to this Flow interoperability standard. So these tests are conceptually, that we're looking at here, are not all that different from Elixir function guards. So a code path should only be taken if a function guard resolves to truthy. And so you can see at the example at the bottom there, you can see contact.age. You give it a context as the second argument to that function. It evaluates that expression and then gives back either true or false in this case. So to support those kinds of expressions that we need in order to support the Flow interoperability standard, we had to write a parser and an evaluator for this. And the first bit that Federico talked about, we just use the Elixir parser to parse everything. But for those expressions, we can't, because those are just strings, and it's a different language, essentially. And so we wrote a parser for this using Nimble Parsec. Has anyone here already been playing with Nimble Parsec? Great, cool. So Nimble Parsec provides a set of primitives for writing efficient text-based parser combinators, and those can then be composed in different ways to make more powerful, other higher order combinators. So on the example on the right defines a parser that allows us to parse a simple Lisp-style expression. And so if you can see the code, I don't know if it's readable, but you can see that I'm defining at the top start parameter, parenthesis, and close parenthesis. Basically, we're looking for brackets, and then we have 4 operators that we support: plus, multiply, I think minus, and divide by. Then we define white space. We defined operand, which can either be an integer or an expression itself. And then we define the parser at the bottom, which basically says a Lisp expression starts with a bracket, then an operator, then some amount of white space, followed by 2 arguments, separated by white space, and then a closing parenthesis again. And so it's really quite interesting how quickly you can kind of build a fairly powerful expression system using Nimble Parsec. And so this allows us to build this kind of stuff. And so the example at the bottom there, it does an approximation of getting close to calculating the, I think it's the radius or the diameter. Anyway, it approximates pi and then does the, multiplies it by 100. So once you have a parser, you get an abstract representation of the expression, the abstract syntax tree. So if we're parsing the expressions that we were looking at earlier, you can see it just returns a list with lists. Once you have that, you have your code essentially as a data structure, and you can do all sorts of really interesting things with it. One of the first things you would likely do is build an evaluator for it. And so for our abstract syntax tree, the first item in the list is always the operator. The remaining items are the 2 arguments for that operator. And so at the bottom where it says eval AST, you can see we're converting the operator to an atom. We're just calling kernel apply that atom, and then we supply the arguments. And so what's happening is that first we're evaluating 2 times 3. The results of that is then applied to the next expression. We're adding 1 to that, and we end up with 7. Again, it's a pretty simple example, but it really does show the power of these kinds of expressions. Especially when you start being able to compose them together in interesting ways. Now this is not the expressions that we work with. The parser for that is quite a bit more, but I'm just using it as an example to show you how you can build a parser using Nimble Parsec. So for our expressions library that we developed, we take the same approach. So we wrote an open source parser for these expressions using Nimble Parsec, and like the previous example, it returns a simple abstract syntax tree. Now the AST is a little bit more complicated than the example we were looking at earlier. So in the first example, you're seeing hello at contact.name, and then you can see that first what it returns is just the string hello. It doesn't need to do anything with that, but then as soon as it hits an at something, it knows it's an expression and it needs to do something with it. And in this case, we are reading the property name off of something called contact, and that's what it should do. So the next example below that, it does the same, but then it introduces a function. So at proper, which in the expression library, it titleizes the arguments it receives. And you can see it's a nested abstract syntax tree. First, we're reading the property name off of contact, and then we're applying the proper function to whatever the result of that was. And then when you evaluate it, we do hello at proper contact.name. We give it a context. As you can see, I'm passing in contact.name. In this case is Mary, lowercase, and it comes back with hello, capital cased Mary. So this simple expression language actually becomes pretty powerful surprisingly quickly once you have this in your application. You start doing things with it. So it allows us to do all sorts of personalization, calculations, and substitutions using a dynamic context. Example that's on the screen there, you can see that the response is personalized to me, in this case in a chat message, and it automatically calculates and formats the date for my next appointment in a month's time. Which is pretty incredible to be able to just do that and say, okay, I've got a bit of text, here's an expression, evaluate it against my context and send me a personalized response. So we already mentioned that expressions really power the decision-making logic in the flow interrupt JSON. That's why we that's why we created the parser. And we hinted that these tests in the JSON were conceptually similar to function guards in Elixir. So when we compile the DSL down to JSON, you can see that the guard when resp.status equals 200. So what we're doing here is we're calling a web API, in this case example.org, and we then, when that's done, we go to the card called next, and then it figures out which card applies for the state that I'm in at the moment. And so if resp.status is 200, which means we got a successful response, use that card, and otherwise go to the next one. So when describing these cards, we're using Elixir guards, essentially, function guards, but then we compile those down to expressions and embed them in the flow interop JSON. And so the first one at the top, we're using an expression block, which means you can just use it without an at something. And so we're just evaluating resp.status equals 200, which is similar to the example we were looking at earlier, contact age greater or equal to 18. That returns a true in this case. And then we evaluate the text, and then we embed the expression inside the text string. And so we say the URL was resp.url, and the status was resp.status. And so you can see what the evaluated end result is there. And so then it becomes quite easy to just join that into a string and send it back as a response. And it just, at that point, it just becomes regular string interpolation. So expressions are almost valid Elixir. Can they be Elixir? So if you quote a bit of Elixir code or Elixir expression, you get the code representation of that. We were looking at that earlier already. So we're doing contact.name, and you can see it, well, I don't know if you can read it, but basically it does the dot operator on contact. So if we parse a block and we do the same, and we say parse block contact.name, you'll see that our abstract syntax tree looks a little bit different than the Elixir one, but it's basically just data. You can do all sorts of interesting things with it. And so you can take that data and then you can convert it into quoted Elixir. And then you can use Elixir's code tools to just generate code from that. And in this case, that's what's happening here. So we take an expression, we parse it, we generate Elixir quoted code from it, we wrap it in a function. That function expects a context, which is the context that we supplied whenever we evaluate it, and it returns the value for us. So it's pretty powerful once you have this abstract syntax tree to just kind of transform it in whatever way you want, and then in this case, we can generate a valid Elixir code from this. And so this means that for us that these compiled functions can be cached. If those functions are pure, they can be memoized, and it gives us a really interesting performance boost under certain situations. So the previous example looked at variable substitution. How do we handle function calls? Like the example that I showed earlier with proper. So the context applied to the function requires a callback module. The callback module implements a behavior that basically says there needs to be a function called callback, and it takes 3 arguments. The first one is the context itself. The second one is the name of the function that you're calling, and the third argument is the list of arguments to that function. And so at the example here, you can see that the code is being generated by the compiler. It first calls the inner function proper, and it just supplies one argument, which is whatever the variable is in the context under contact.vars. And then it supplies the results of that as one of the 2 arguments for the concatenate function. The first argument is just a string hello. The second argument is the result of the first function call. And then that returns that again. And so you can see those modules, the callback modules are just implemented as regular Elixir. And so it becomes really convenient to just add more functions to it as one would need for whatever use case you're trying to solve. At the bottom there, you can see that we're compiling it. We get back an actual Elixir function that we then supply a context. It'll evaluate it for us, and we get the value back. So the really interesting thing about this is that it really allows us to rely more on the Beam VM to evaluate these things for us, make sure it's correct, but also have a lot of like the code introspection tools that the whole ecosystem gives us in order to find out what is this expression doing, is it doing what it's supposed to be doing. So let me see if this, I'm going to have to find my cursor, where is it? So having these kinds of low-level functions in an interactive document fashion, much like Livebook, with a real-time simulator that Federico talked about, turns out to be incredibly powerful. And so it allows us to describe some solutions to fairly complicated problems. So this was a demo we did for the BBC. Did it already finish? It didn't start. Okay. This is a demo we did for the BBC. Is it running? Yes, it is. Cool. And it's about 60 lines of code in the DSL. And this was built in response to the invasion in Ukraine. BBC was blocked in Russia, and how do people still access reliable news? And so one of the means that we were looking at is like, is it possible to surface a podcast from the BBC over WhatsApp? Because WhatsApp was not a blocked medium. And so 60 lines of code using this DSL, I'll run it again because I'm still talking, it allowed us to build a simple podcast player over WhatsApp, a completely secure encrypted channel, to allow people to get the latest news up to date on their phones in their pockets. And so what we're doing here is we're using the DSL to read the podcast RSS feed, present a menu over WhatsApp, and allow people to interact with it. And this is a live environment. And you can see that, well, you could see the editor actually shows you where you are in your application as you are interacting with it. And I think this is part of what Jose was talking about this morning as well. Being able to see how a system works is so important for the learning, to understand it so that you can actually get to the solutions that you're trying to get to. So this is what we're using Elixir to do. We're trying to build the world's best possible runtime to have an impact with. And we want to see replicable, evidence-based solutions that scale effectively to support vulnerable people everywhere. So this past year, as I said, we launched services. The first service we launched with this was in response to the invasion in Ukraine. And we did that for the state emergency services in Ukraine. And we're really proud to support them and to continue to support them. And we're really proud to be in great company of such great organizations like the UN Refugee Agency and the WHO. So we really need this concept of systems with low floors and high ceilings, systems that invite us to find and launch solutions to some of the world's most difficult and hardest problems. So Turn revolves around this question. Technology is one of the greatest tools in human history to affect change in terms of speed and reach. And so let's use it effectively. Like we're all at ElixirConf. It's an amazing language, an amazing ecosystem. We can use this to affect social change and really shape the societies that we want to be living in. And so we all know what the tech industry understands as a unicorn, privately held tech startups valued at over $1 billion. I'm kind of getting tired of that definition, and I think we should redeem it and reclaim it. 4 billion people use chat apps on their mobile phones. I think we can reclaim the definition of what a unicorn is, and we think there's an opportunity for social unicorns, positively impacting 1 billion people, changing their lives for the better. So technology startups do amazing things, and I think there's a massive opportunity to affect really important social change through tech. With this definition of a social unicorn, we only need 4 to reach 4 billion people. So while that's a big challenge, it's also a very small number. So I challenge you all, how do you use your skills to affect and impact society, shape the societies we want to live in, and have social change? Cool. Thanks for coming. That was our talk. Thanks for your time. If there are any questions, I'm happy to answer them.
Yeah, I think we just have time for maybe a couple, so yeah, I'll go there.
Hey Simon, thank you very much for the talk. I just had a quick question about your the evaluation of mathematical equations. Like you built something there yourself. Have you looked into third-party libraries like Abacus, for example? And then, if you did, why did you decide for building your own DSL in that case?
I have not looked into Abacus. I probably should. So thanks for that. We did not invent our own DSL. The reason we went with the expression language and nimble parsec is because it's an existing standard on the flow interop. And so we want the great ideas that emerge on Turn to be replicable on other platforms, which means we need to align with that standard, and we just needed to build a parser and evaluator for that specifically. So if Abacus could have helped us with that, or can help us with that in the future, I'd love to hear. Our priority is building great solutions. If there's better ways to do that, fantastic. I want to know about them.
One more.
Yeah, actually in the editor, sorry, I didn't, so the question was, sorry, the mic didn't work. The question was, in the editor, did we do things like autocomplete and add that? Yes. So the editor actually gives you feedback in the same way that Livebook does. It gives you the same autocomplete functionality, and when you're writing things, it gives you the errors on, hey, this is a syntax error, or things crashed right here, or this is a function I don't actually understand. The editor we're using is the same editor as Livebook does, and it has some great hooks in there to provide that kind of feedback. So there's constant evaluation happening in the background, which gives code insights and stuff like that. Yeah, thanks. Great question. Anything else?
I think we're at time, sorry. So yeah, let's thank again Simon and Federico for this inspiring talk. Our next talk is happening in like a few minutes, so yeah, no time for coffee break now. So yeah, see you in a bit. Luca Deizotti. Please, yeah. Thank you. Our next speaker is Luca Deizotti, following up from José's incredible keynote, Luca will be exploring a very interesting problem. How do you debug a live system when you have fairly limited access to it? So yeah, José showed the great power that Livebook has. And yeah, Luca will be showing a concrete example of how to debug a system when you have limited access. So luckily the Beam has some great capabilities around tracing, and you can basically hook into the message passing of anything you want. And yeah, Luca will be teaching us about that with a concrete example. So yeah, let's all welcome Luca to the stage.
Hello, everyone. Thank you for being here today. Pretty excited to be sharing the stage with people I usually follow on Twitter, so please be patient with me. Not here to teach anything to anyone today. So, who I am? I am Luca. I am an engineering manager for Prima Assicurazioni, which is an insurance company that is also the sponsor for my travel today, so please show some love if you can. The problem I want to explore is pretty simple, and it is our problem. I'm still a software developer. And it is that the world is complex, that software development is a hard discipline, and we don't help very much making things simpler, usually. So we just write our software, and we pack in some way, and we usually end up in a couple of situations like we deploy our software on some premises, we choose Fly.io or Heroku, and we deploy it as a SaaS, or we enter the microservices hell and Kubernetes and whatever. And all those kind of deployments have something in common. I'm not addressing something like desktop application today. And the thing that they have in common, we will see later. What happens then? We deploy our software, and usually if we have been good developers, we instrumented observability, we choose some service, around 1,000 out there, just to see what is happening into our infrastructure, not related to any of those services, of course. Through observability, we just gain a lot of insight into what is happening into our system. Most of our libraries, the tools, are already instrumented. They support OpenTelemetry or whatever we prefer. But what is not covered is that we are the ones who write the core business logic. And we, or at least I, make mistakes. We forget, we didn't think it was important to instrument observability at that certain point. Our super senior colleague said, no, don't use Phoenix because it's bloated, just use this library, whatever. Or someone said, no, you have to use this library that has not observability included. Or we simply tried and got it wrong. That is probably the most common. Now, in almost all the technology stacks, we are pretty lost in the dark. We can take a look at the logs, we can watch a core dump or whatever. But in our case, we had something in common, and it is that our nodes are reachable, hopefully, if our plateaus operations, security operations allows, of course. And then we can see what OTP gives us to rescue us. Now, this is not a talk about errand distribution, so there are a couple of slides here that I will jump right away. You can take a look later if you are interested. But what is interesting about the Erlang and Beam distribution in this case is that I say that the nodes connect between themselves. Wow. They are reachable. They have a name that we can resolve in some way through our system. And when we connect to a node that is part of a cluster, we connect to the entire cluster. And it's a pretty interesting thing to know. Now, there are some slides that I will just jump. Forgive me. See them later. This is not a talk about distributed system at all. But let's remember when addressing this kind of situations that we are in a distributed system. So bandwidth is not infinite, big messages, latency exists, don't expect your messages to come and be in a certain time. Network can fail, is insecure, we have the CAP theorem and all the variations that have been born through the years. I wanted to jump just to the demo because I like it. So I prepared a simple application that we will totally forget it is a Phoenix application, okay? It is just a generic web application with a couple of REST endpoints. It is up with a Docker Compose, but again, just to avoid the networking problems today, sorry for that. Let's suppose it is in production, so we have just a channel available to reach it. Okay, we have two names. They are Ratchet at Ratchet 0 and Ratchet at Ratchet 1. Let's jump directly to the live book. The things should be running on my notebook now. Sorry, I also thought I would have had a mouse, so some interaction may be clunky from my side. Sorry for that. Okay, as you can see, we are in our live book. We have some dependencies installed with Mix, some of the usual ones, and some that I just decided I wanted to. No, of course, this is not working like I wanted to. Okay. A disclaimer of the whole experience is, of course, that the things I will show can probably be done in a couple of other ways, probably better ways. Some of them could have been done just using a remote shell and jumping into the application. And also, I'm not using the Phoenix ability to, the Livebook ability to just connect to our application because I didn't want to enter the context of the application. I wanted to use Mix, for example, in this case, and I wouldn't be able to do if this was the case. I don't know why this is not working as expected. So a basic gotcha of the whole experience is that the host part of the short name that we are using must be resolved through the system name resolution. So just check with my machine that we had the IP addresses of our instances. Of course, this becomes a networking problem respect to our company infrastructure. Okay, we just care that the application is reachable. Now, just check that I spin up the Docker instances, which I did. Whoa, good. Let's just, this is the setup phase, please be patient. Let's set up some configuration, like the node that we will use as a main target for the experience, the node that we know about, the cookie that is, let's remember, a mechanism for separating nodes on the same machine. It is not a security mechanism, so let's remember this. From the networking side, and the endpoint that we will reach the most. Let's see if the shortcut works now. Okay, thank you. So a basic way to connect to a remote node from a shell or a live book is using the function that we had from OTP, Erlang, and Elixir. We have a set of functions that are really sparse in some modules in the Erlang way. So we have netkernel connect, node connect from Elixir, netadmin ping that answers us with a pong, and we see that our application is reachable. Now, we can just use the AIPC module to execute remote calls to our target node, just like Jose showed before. So we see that we have the node self of the current node, that is livebook something, and we can execute the same operation on the remote node, so getting our ratchet at ratchet 0 result. Let's, again, let's prepare a small utility just to wrap up some APIs without too much bloat, not important the code here. We have our server up, we have a way to reach them through a REST API. Let's see, okay, we have an answer from our node. We see that the node knows himself, he knows Ratchet1 that is his twin, and he knows the livebook instance that just connected to him. Let's enter the real debugging moment. So we suspect, ideal situation of course, that there is an endpoint that is causing some troubles in our application. So people are reaching out to the API Fibonacci endpoint, but they seem to wait too much for their result, and they're paying for it. So let's see, okay, normal call, normal time. Let's try with a greater number, and we see that we start waiting way too much. So 5 seconds, way too much for a Fibonacci number that isn't arriving. We have to understand what is going on. The first friend that we will have in this experience is DBG from the batteries included with the beam, and it is maybe the second most basic tool in the set that is given to us. It uses LM trace under the hood, which we will not use today. And let's do a little disclaimer. Let's remember, tracing nodes is not easy, because when you trace too many things, you will make your node clunky. if you trace a function that is used by your tracer, you will have a deadlock. And of course, you have to know a little about your system because deciding what to trace is a science driven by anger, coffee, tea, tears, whatever you prefer. A typical DBG session usually looks like a setup phase where you just start the stuff, a configuration phase where you decide what you want to trace, you let the application make some noise or you just poke it a little, and then you read the result. So, in our case, let's pretend we remember a recent ticket on substituting an old clunky old Fibonacci function with a brand new tail Fibonacci one. But we don't know if it has been merged, shipped, whatever. So let's see. First of all, let's stop any DBG process in the remote machine. The leader self-promotion time, while playing with this, I just created this smart cell to learn creating smart cells. It just does these things, or connecting through a node through normal distribution and executing a simple command. We will not use it a lot today because it's pretty graphically intensive. So let's start DBG on the remote node. I hope you see the comment where there is the actual command that is executed. Now, we started DBG. We will start what is called a trace port for handling trace messaging without passing from the beam messaging. So it's really low profile. Not free, but still low profile. Also, the port will be created on the remote node because we cannot trace a remote PID on a local node and vice versa, so we just wrap everything in our AIPC calls. The result is a function that returns a port that is suitable to be passed to DBG tracer. That is another function that we will use. Please go here, okay. A little note on the port configuration, sorry for that. We passed a single file name as a parameter here, the traces one, but we could have used a more complex configuration like a maximum number of files, maximum size, maximum time for a file to be opened, a wraparound configuration, so pretty complete configuration. Let's remember that tracing is not free also space-wise, okay? So let's start the tracer on the remote node using DBG tracer. We see that we have an OK on the node that the thing has been executed to. And now we are almost ready to start tracing. We will use dbg.p, pretty expansive name like Erlang, like always. P stands for process. And we are just saying, OK, let's trace multiple processes or port, and let's do a little initial filtering to the messages received and sent. In this case, we are, of course, tracing everything because we can, and, but only the calls, not the messages. So just a little of forgiveness from my side. Let's evaluate it. I don't know, it is jumping. We see we are matching on 288 processes here. So now we can check if our alleged function, old Fibonacci, is called. Let's create what is called a trace pattern. A trace pattern is a set of module function arity and a match specification that, for the one who may not know it, is like a regular expression for Erlang code. And this will enable DBG to understand what to narrow down in the trace. So in this case, we will just match the module ratchet math Fibonacci, the function old Fibonacci with arity1, and we will use a catch-all match specification just for cheating a bit. We also have, of course, a couple of built-in match specifications from Erlang, which we will not use today, but it's nice to know that they exist. Done. Now we are set up for this first round of debug. Let's generate some noise. Of course, in production, be cautious because there may be destructive APIs. You may have to wait for the tracer to receive something. Let's now see what it is inside our remote traces file, and we will see that we have some binary content. Honestly, we could have just do a cut on this file and see some function calls, but for the sake of completeness, let's create now what is called a tracer client. It is a process along with a handler function that takes messages from a port and interprets them. In this case, it is super easy. It is like just does a file write on a traces translated file with, oh, I called this, okay? Nothing fancy, but we have an error. It is a wanted error. Why? Because we just created a local function and tried to send it to a remote node, and it has not been really super friendly for him. We can achieve a similar result. It's horrible to witness, but you can do it using a code eval string from Elixir, or the equivalent from Erlang, just by wrapping up your code in a string and send it to the remote node. Okay, so we are evaluating eval string on the remote node, and we now have our handler function for the port. Of course, we have other ports available with Erlang, like an IP port that sends the traces to an IP address. But in our production environment, it may be difficult to just open another port, another IP, so I just went to the file option in this case. Now we should have a traces translated file, which we have with our calls to the alleged function. Okay, nice first step. We have our alleged function. Let's stop the tracing, so we remember that it is low profile but not free, and let's do a step back. We did a lot of stuff for a super simple use case, right? And we didn't benefit from Livebook as greatly as promised. If we forget, of course, the stuff that Jose already talked about this morning. So we have a versional, configurable, a collaborative playbook, a nice UI, UX that is more reachable to the users. We had Mix to use some dependencies, and we had, if we wanted, some boilerplate smart sets. We could already have get something more, like in this case, I'm just trying all the APIs until I reach a 2 seconds timeout, and I can just plot something that makes me visually see where the problem starts to be, because I not only want the fading number, I want to see the exponential way for things to go. The Beam comes with a fully integrated suite of tracing tools with different aims. We will see just one if I had time today. But let's do a step aside this time, and let's try to solve the problem. Why? Because I know it is a super bad practice. Don't do it, but sometimes you just have to solve stuff before your CD, deploy pipelines touch production, or maybe you don't have continuous deployment or whatever. You just need your software to work because your business is at risk or lives are at risk, so whatever. Let's see how we can solve the problem in production. Now, we have found the guilty function. We have the module, which is luckily a pure module, so we have to do a little less steps to solve the problem. And this is the guilty module. We see that we have a call to the all Fibonacci function. So let's just copy-paste it to our Livebook and evaluate it. You see that we have this tail Fibonacci, that is the right function that I want to have in production. We have some binary code here. We could have removed the old Fibonacci function, but we don't know if it is dynamically called somewhere, so let's just keep it, don't play with fire. As you can see, we have the binary of the module, we have a connection. We understood that we can load live code on the remote node. So let's use again our AIPC call and use code load binary to load the binary of the module on the application. This path is ignored in the load binary, but it's still needed. Let's see. And now the function is really fast and has the correct result. Yeah, otherwise it would have been really awkward at this point. Unluckily, what happens if we restart the application, this fix will be lost. In this case, although it is not optimized, you could just write the binary module, the binary code of the module on the right path, and you would have persisted the fix. We don't need it at the moment. There should be also another way, but I don't know it yet. We don't need now the fix to be in production, so we just restart the application, and we should see that the code, okay, it is still slow now, and it's what we were expecting. So let's see another scenario. We saw a simple one before of this one, right? But what if our function was the result of more function calls, okay? So we could have just this endpoint, this number info, that gives us more information like a factorial, a Fibonacci number, a square root, and any other information. In those cases where the result could have been the result of API calls or function calls or whatever, I find it really useful to use flame graphs that are just graphs that allows us to see the execution span of a function from both a vertical perspective, like the function calls that compose our span, and the horizontal perspective of the time that each of those functions takes. So we'll just drop to a useful library by Status3D that is called eFlambe, both from Erlang and Elixir, to generate traces that can be rendered as a flame graph. But we don't have it in production, right? We have installed it using mix install, but we don't have it in production. But we have a connection, we have a library, and you already guessed it, we are gonna load it. The first time I had to perform this, I just did it manually, so just load a module, doesn't work, load another module, doesn't work. But then I read the documentation, yeah, and I discovered that there is this application get key that gives me all the modules of the application, so let's just reduce them for comprehension and load them on the remote node using, again, code library. All we need to know now, similar to DBG, is to start the eFlambe application and try to apply our function. In a real case scenario, equally to what we did with DBG, we could have just captured our execution flow and waited some time. In this case, we are just applying a function. Two little gotchas here. I had to explicitly enable the XML application in the Phoenix application because I wanted an SVG and not a brand and grab format, and also because I wanted an SVG for this talk and not making too much code, I used a modified fork of eFlambe that embeds a non-code asset like an SVG header. In this case, you see we're just doing an eFlambe app start, and then we apply our function ratchet get number info with 11. So again, some little knowledge about our code, our system in this case. This is the supervisor terminating. You see that we have an SVG, an XML content. So when I started imagining this talk, I had in mind writing a smart cell, looting other visualizers, just to show the flame graphs in this live book. But then SpawnFest 2022 happened, and Status3D again made eFlambe live, so it allowed me to do this talk because I wouldn't never been able to write really that smart cell. And we can see that we have our flame graphs embedded in Livebook. Here we can see we start from the apply, of course, in a just a capture way. It wouldn't have started from here. We see that our get number info is called. We see a pretty fast square root, a less fast but still decently fast Fibonacci factorial with its own reductions, and then a super long guilty Fibonacci function. So again, you see that here we have the function name here, all Fibonacci, on the bottom of the graph, and we can see that it has been called. That's maybe for a more interesting use case, and we saw how we could trace live our node. So we have also a bonus track that I gained by jumping the previous slides, and it is tracing with sequential tracing. What is sequential tracing? It is the act of following a sequence of information, just like Jose showed before in his keynote. How does sequential tracing work in Erlang? It is by setting a token on the first process that starts a trace, and then propagating this token through Erlang messaging and other means by documentation, but I don't know what other means in this case. The usage is still straightforward, and the performance of this is usually negligible. You start a tracer process that will collect the information, again, like we did with DBG. You set some configuration flags. You set your tracer process as the system tracer in all of the nodes. Again, this works by setting something in all of the nodes and then collecting the result. You let the system make some noise, and then you stop the trace and get information. So the context here is we have another way to ask for our Fibonacci number. You ask Impero Frederick II, who hosted a mathematician called John of Palermo, who proposed problem to Leonardo Bonacci, aka Fibonacci. But those people just message themselves through different nodes, not on the same node this time. So let's see what is happening with sequential tracing. we fall back on the same take. The code is not important here. It's pretty messy. I'm just cutting down a lot of live book messaging just for the sake of clarity. The code is pretty ugly, if you let me say this. But again, we have the module. We will load it on both nodes this time with the usual comprehension and the ARPC call to code load binary. And then we will, with an helper module, just set up the tracer on all the remote nodes. So we start the tracer, we set some token like trace the sends, trace the receives, use a strict monotonic timestamp, set my tracer as the system tracer, and then we load on both the nodes. Here is livebook crashing for I don't know which reason. We do the same thing on the local livebook because it is from here that stuff will start, and we just call our Imperial Frederick II John server that is giving us the correct result. And let's see how it did it. So let's collect the trace, again, using a Gen server call to the remote traces. We have a big number of traces. I have 4 minutes left, sorry for that. And then again, not a super nice code. It just loots something from the local sequential tracer that ships with livebook and tries to get a sense of what is happening between the nodes. You see a lot of useless code. We have our module, and we format it in a mermaid-friendly format. In this case, I did a mess with timestamps, and you see the order of the messages is not correct, but we can tune it a little and get the correct result, I promise. So this was like what I wanted to show about the demo. We already went to our live book. The takeaways I want that we get from this is that livebook can be useful also as a graphical tool for debugging purposes. That is a non-trivial application, maybe because we have a versionable tool. It is really more handy than copy-pasting stuff in the shell and then exiting because we forgot a parenthesis or stuff like that. It is a repeatable, it is a graphical, it is a reachable tool. But also I wanted to underline that debugging live system is a fun activity. It is, but it is complex. It will break things. It will break the immutable software rule. It will poke in production. It will throw you in a black hole of despair while you're trying to understand what is happening into your system. But still, OTP gives us, and livebook gives us a lot of tools to address those kind of happenings. These things, in my opinion, can save your business, and sometimes, depending on the mission criticality of your application, even more than that. The code is available, or ugly but available. The gotchas are listed. I hope everything was clear because I have to be pretty fast. I didn't want to cut any content, so really sorry for that. I am available to any question even later. If I can answer, I will probably not be able to answer, but thank you. And again, thank you again for being here today, and thank you for ElixirConf, sorry.
Thank you, Luca. I think we have time for a few questions, a couple of questions. This is so huge, yeah, back there.
Hey, first of all, thank you so much for the talk. That was awesome. I just had a question, or I guess kind of a comment kind of question type of thing. Is like, we saw this, and this is obviously, you had to do kind of a lot of things just to trace your functions as you were going through them, and especially distributed things and everything else. Do you think there's room for some sort of wrapper or library to improve the developer experience? Because this seems like a lot of, as you said, dark hole of despair in order to just trace through your application. I feel like there must be something more that we can do there, no?
Yeah, honestly, some other libraries exist, but they usually already covered in blog posts and whatever. I don't remember the name at the moment because I'm kind of excited, but I will write them later. So some wrapper already exists, but of course, it is another of the things that I wanted to show, that you just can write your own as a test, as a way to debug your things, and then understand if there is a room to stabilize them, to give them a form, and give them the dignity of a library. And in my opinion, there is a lot of space here. Yeah. So thank you for the question, because I think it's important.
We have
I
one more.
hope it answered to the question. Okay, sorry.
Cool. Yeah, one more here.
Well, first, thanks. It was amazing, nice journey. But I was wondering if things wouldn't be easier if you installed like the Kino and all the other libraries like in the production cluster just in case, and then use the live book to connect like as the remote, like instead of like the mix one connected, like the connected mode to the server.
Yeah, of course, having already the tools is good. But sometimes you just didn't know they exist, for example, in this case, or you didn't just want to add more complexity or more space to your program. That's the case that I wanted to address. But of course, if there is something that you already know in advance that you will need, in my opinion, it can be okay to just add it to your system. For example, not exactly the case, but I had to add XML to the application in this case. It wasn't enabled by default. I just took a choice, of course, by convenience, for my convenience today, but it is a little example of this. Yeah, you decide what ships with your application, and that's, of course, something that you can do.
Thank you.
Hope this answers.
Thank you for the talk. Can you share your experience with debugging like in real life? How did that go? What the problem was?
Yeah, the first problem that spawned this talk in my mind was like an n+1 query. Or not exactly an n+1, but pretty similar. It was both n+1 and a slow query. So we were really trying to understand why the execution flow of the program was arriving there, but we couldn't replicate it. We had the test, we had really a lot of tests in that application, a legacy one, of course, but we couldn't understand. So we just took the staging environment, in this case, not exactly production, with some data from production and tried to debug the real things that were happening, because we just couldn't replicate on our machine in the test CE. So that was the problem that spawned the idea. And we just did it. I just did the flame graph without the live, the smart cell. I loaded the library. I tried once one flow, another flow, spawning stuff from the UI, a lot of things, and then we tried to understand what was happening. I don't think it was what enabled us to resolve that specific problem, but I saw some power there.
So let's give a big round of applause to Luke, and thank you. 1, 2. Oh, cool. Thank you. So yeah, welcome everyone. Our next speaker is Wojtek Mach. So Wojtek works at Dashbit, helping organizations adopt and run Elixir in production. But perhaps you know him as being a part of the core team of Ecto, X, and XDoc. So if you've ever built cross-platform applications, you know that it's a very hard task. And keeping up with the Livebook team this morning, Wojtek will share how the Livebook team developed the Livebook desktop application, how the open source technologies they've used, and the lessons they've learned in the process. So yeah, let's please welcome Wojtek to the stage.
Thank you. So, yeah, that's a big room. No pressure. I'm Wojtek, and I'm going to talk about building Livebook desktop. So, Livebook, you may have heard about it today. It's a interactive and collaborative code notebook written in Elixir for Elixir. You can write some Elixir code, execute it, see the results right away. Again, you probably heard about it already today or before, but if you haven't tried it yourself, I definitely urge you to do so. I think it is actually pretty magical to use it yourself for the first time. And that's actually one of the reasons we created Livebook Desktop, to make that super easy. So on the livebook.dev, there is the install Livebook link, and then there you can see that we have installers for Mac and Windows. And here they are in action. So on Windows, you download one file, you have the setup wizard, and on a Mac, we have something similar. And basically, after installing and running it, you would see something like this. So this is on my Mac. In the top right corner, we have the Livebook icon, indicating that the Livebook desktop is running. And we have some options. We can open Livebook. So that's going to open Livebook in your web browser. So it's going to be pointed to localhost. And then we also associate the exported notebooks, the .livemd or live markdown files with the app. So if you double click on these files, we would open them in your browser. So there were two main reasons why we created Livebook Desktop, and this is installation and integration. So installation, if you already have Elixir installed, then it's super easy to use Livebook. You can just mix escript install Livebook from Hex and then run Livebook server, and that's it. If you don't have Elixir, but you have Docker, then it's really easy you can just run this command to use the Docker images that the team maintains. Going back to the first one though, so this assumes you have Mix, that you have Elixir. So kind of getting there, on a Mac, you might be using Homebrew, so brew install Elixir. Under the hood, that would install Erlang, because Elixir depends on Erlang. And then Erlang depends on OpenSSL and some other things. And then, like, first you need to install Homebrew, and actually you need Xcode or Xcode command line tools to use Homebrew. Now, all of that is pretty seamless, like a lot of the stuff is gonna happen under the hood, but it is there, and each step is a potential for problems. Now, you would most likely never hit these problems on the first run. Again, it's pretty seamless, but what may happen is you got everything working today, but then 6 weeks or 6 months later, you update, and maybe like unintentionally, you update one of these dependencies, they are global, and that could break your app. One of the goals with Livebook is, I think we can really help the getting started to Elixir experience. Again, it's a code notebook, you can write code, execute it. So I think it can really help with new people to Elixir, but then, or even new people to programming, but then if they hit any of these problems, this is really tough for them. So again, with Livebook Desktop, you just download one file and you're good to go. The other reason for Livebook Desktop is integration. I alluded into that already. So we have the association of the .livemd files. We also what we do is on the Livebook homepage, in the top right corner, we have two buttons. So the create badge button is gonna create a badge like this, run in Livebook. And that's gonna do, what that's gonna do is if you click on it, then it's gonna import a given notebook into your live book, but like which live book? So this is where the other button, the settings button, comes in. You can configure your live book installation, like the live book URL. And if you use live book desktop, you can check this checkbox, and it's gonna this running live book badge is gonna open notebook in your live book desktop. Another example of operating system integration is this. If for any reason, which by the way never happened, if for any reason we failed to boot Livebook or Erlang, then we will show this error dialog. We have a button to view logs, so hopefully this way you would be able to find the issue, fix it yourself, or report a bug. We support all operating systems as long as they are called Mac or Windows. Notably, we don't support Linux, at least not yet, and this is where we need your help. So we are a very small team, so we have to pick our battles, and so we focus on making the macOS and Windows rock solid before we can commit to another port. But if someone, maybe someone from the audience, would like to start Livebook Desktop for Linux, like a community-led effort, we definitely endorse that, and we would happy to assist. All right, so building Livebook Desktop, we had to start somewhere, so this is where we started. I personally think it's pretty interesting. On the Macs, applications or application bundles are actually just directories with a particular structure. So the folder ends with the .app extension, and there is a particular set of subdirectories. And if you put a file into the contents macOS and then usually the name of the app, that's like the application launcher or the entry point. Usually that's going to be native code or compiled code, but it can actually be any executable. So like on a Unix system, that could be just a bash script, or in this case, an Elixir script. And here we use the WX. So that's WX Erlang or Erlang bindings to the WX widgets, cross-platform GUI toolkit. It ships as part of OTP, so it's really easy to use. It's just there. And yeah, here we just initialize it, create a frame or a window. With a title, we show the window, and then we sleep forever. And after making this file executable and opening the app, it just works. So pretty easy. Like, how hard could it be to build the whole app, right? So kind of decomposing this. So I'm gonna focus on code. There is the whole other world of packaging up the code. Like, we need to ship Elixir and Erlang and OpenSSL and all as part of the app. So I'm not gonna really focus on that here, but just on this code. So this is just a script, so not really production ready. So something more structured would be to put that into a gen server. And then what we can do is WX has this connect function which subscribes to events. So we can subscribe to the close window event of that frame of that window. And then we are gonna start getting messages. So when that event happens, we are gonna get a plain Erlang message. And because we are in a gen server, we can handle that. And I think this is actually pretty nice API. Like it, very much Erlang. We just send some messages, handle messages. I think it's actually pretty great. And again, if we run this, we are gonna get this window. Notice that in the top left corner, we have the menu bar. So on a Mac, there is a global menu bar. Applications takes turn in kind of taking it over. And automatically we would get this menu bar with some menu items. There is a quit Erlang item there. And if we click it, nothing happens. So I guess that makes sense, right? Like we have some event handling. So there is the command menu selected event that happens. And then we have some handle info code to do that. Okay, so we try again, and nothing happens. So on a Mac, again, we have this global menu bar that WX Erlang initializes for us. And like it's already there, and we cannot really handle any of these events ourselves. So what we ended up doing is this fix macOS menu bar. So just on a Mac, what we are gonna do is we are gonna kind of recreate the whole menu bar, and then it works. So okay, like that still works, but like the solution starts to show cracks just a little bit. it ended up not mattering at all because pretty early on we decided that like we actually don't want like a regular app with GUI. We want like a menu bar app, which again, as I showed before, we just have the GUI, just the menu bar icon in top right corner. We don't have a GUI window. Now people ask about this, like there's the whole Electron, WebView apps. Why doesn't Livebook is like that? Two reasons. First reason, there is complexity there. We actually give it a go, and there were limitations. There is an even bigger issue though, which is that if we like embed a web browser, or even we like have some code that connects to web engine that's on operating systems, if there is a bug, if there is a security bug around web browser, then we are on the hook for that. We need to release a new patch. So by not doing that, like it's your browser, it's your responsibility. So we kind of focus on we can focus on other stuff, and there is plenty of other stuff to focus on. So just minor note. Again, this top right corner, the menu bar icon on Macs, the convention tends to be they are monochromatic, and there is actually a platform call to make this kind of like a special monochromatic icon. They call them template icons, and it's actually kind of cool because this icon automatically is going to be dark on a light background. It's going to be light on a dark background. So I think it's kind of elegant, but in WX widgets there is that API call is not exposed, so we cannot do that. And that's something to keep in mind in these GUI toolkits. They tend to be like lowest common denominator. Sometimes they would expose like escape hatches, but sometimes they won't. And here they don't. So we have this GUI app, or rather this menu bar app. It doesn't really have any GUI, but then if we switch applications, it shows up in the application switcher, which doesn't really make sense because there is nothing really to switch to. So, and then it shows up in the dock, doesn't really make sense. So how to disable it? There is a configuration that's part of the application bundle, which I think is pretty elegant as well. And what we would do is set this ls UI element to true, saying that like this application is actually this menu bar thing. It shouldn't show up in the spaces. So we do that, and it doesn't work. And then I went into a rabbit hole, and I ended up, I found myself all the way back in, all the way down in Objective-C in WX widgets, and on this call, which sets activation policy to regular. And what this call does is that, like, no matter what we set in the configuration, this is going to be a regular app, like a GUI app. Fortunately, there is some commentary, and it says that we need to activate the application manually if it's not part of a bundle. Otherwise, basically, it's not going to work. But my app is part of a bundle. So, like, whether it or not it's a part of a bundle is like a different, different conversation, different bug. But that aside, there is more commentary, and they say, note that we have not one but two methods to opt out from this behavior. So someone obviously ran into this. And we ended up using one of these methods, so we overloaded one of the functions, and I sent a patch to OTP, and it got accepted, which was great, but then there is a problem, which is the time before this fix and the time when the fix is out in a new release. During that time, we are on the hook for maintaining OTP fork ourselves. So that complicated things just a little bit. In any case, moving on, there is a subscribe events function, which is really great. It allows us to capture events like the application was opened, the application was reopened, maybe a file associated with the application was opened. And again, I think this API is really great. Again, we're just gonna get Erlang message. We can handle info, have a handle info callback. Now, as I was testing this, I noticed that once in a while, I would like double click on a notebook file and then nothing happened. But then on the second try, it would. So kind of random, I don't know. I didn't notice that, no, it actually happens every time when the application was not running. And then I start application by double clicking on this file, then it didn't work. So that was pretty scary. And I did some searching, and luckily enough, I found a bug in WX widgets. It was actually a bug all the way back from 2014. It was still open at the time. And then I added like, I wrote some comments like, yeah, the bug still exists, like 8 years later. And here's a very simple way to reproduce the bug. And I didn't think much of it, but it was fixed either the same day or the next day, which was pretty fantastic. But there are two problems with this. So the first problem, okay, the time between the fix landing and then the time there is a new WX widgets version, we are on the hook for maintaining a fork. The other issue, a more important issue, is that the fix happens inside that if statement that we opted out from. So yeah, go back to square one. Anyway, so again, we have this fantastic, I really mean this. I think this is a really nice API. Very important question when you work with GUI, cross-platform GUI things. Does this work on Windows or any other system? Yeah, this doesn't work on Windows. This function just doesn't exist in WX Erlang. There is no support for the stuff in WX widgets upstream. It's really just a Mac-specific thing. So we ended up basically emulating the interface ourselves. In some positive news, in March 2022, Dominik Letz announced that his application, written mostly in Elixir, got accepted into App Store and Google Play Store. And I was pretty mind blown. This is really cool. There is now, Erlang, Elixir Beam running on people's devices. That was really fantastic. And actually, Dominik was, basically from day one of Livebook Desktop, even before we were in contact with him, he was very, very helpful, give us a lot of time, answered a bunch of questions. He really made most of this possible, sending patches to OTP and other things. So a huge thank you to Dominik. And later that year, Dominik had some time between contracts. And I was reminded of this tweet that he has an app in the App Store, and how cool would it be if we had Livebook in the App Store? So we reached out, and he agreed to do a proof of concept with us. And again, either the same day or the very next day, we had Livebook running on my iPad. This is not like emulator, simulator. This is, and it's not like Livebook is hosted somewhere else. No, everything is on the device. So that was pretty amazing. Awesome stuff. So the work to make that happen was that, so before our architecture from the operating system perspective was we had two OS processes. The Swift one is just setting everything up, launching Beam, and then Beam was in a separate process. And that is no-go for iPad. On iPad or on iOS, you can only have one operating system process. That's the limitation of the system. Technically, there is a fork function, but it breaks every time. So not super helpful. So the work was to basically make Erlang embeddable into applications, and that's exactly what Dominik did. Again, sending patches to OTP. As a matter of fact, we actually replicated this setup on Macs as well. And then if we had all of this running in the same process, actually the WX widgets problems went away. And the reason for that was we had this two separate operating system processes, and the WX widgets really expects to be in the main one, so to speak. So that actually solved these issues. Anyway, so yeah, that was a way to make it happen on iPad. Unfortunately, the architecture of Livebook is like this. We have the Livebook server kind of manages the notebooks. And then each notebook is actually a separate Erlang VM. And we do that for a very particular reason. So it's for isolation, so that no global state of the VM would ever affect any other notebooks. We need that for reproducibility and fault tolerance. But this means that we actually cannot have Livebook for iPad because we can only have one process. Now, we could have Livebook Lite. You can only have one notebook, but that feels kind of lame. So at the moment, we shelved the idea. As I mentioned, Dominik was super helpful throughout the project. He started the Elixir Desktop project. And so there is definitely overlap between what he did and what we were trying to do with Livebook. And we decided that there's going to be like a extracted library out of this, like some shared component that we could all use. And we decided to have this app bundler library, which is about bundling your app. So basically bundling the code, the OTP, Elixir, and all. And we came up with this declarative configuration. So we hook into Elixir releases. So in the steps, after the assemble step, we basically bundle up the release. And then, so yeah, this is just plain configuration in your Mix EXS. And then we had this declarative configuration for the app, saying that like, okay, so the app is livebook. These are the custom URL schemes that we support. These are the custom document types that we support. And we had these per operating system overrides that you could use. Like, okay, so use this icon for Mac, but use this other icon for Windows. And I mean, honestly, I'm pretty biased, but I thought it was kind of cool, you know, this declarative thing, but then under the hood, we like solve all of the problems. And the way it worked was we shipped with launcher templates. So launcher.swift.ex. It needs to be ex because we needed to inject some custom code. So we had a launcher for launcher Swift for Mac, and we had launcher VBS for Windows. So VBS, Visual Basic Script. We just started with that, just like the simplest way to start external process on Windows. As I was testing this, I noticed that like if I opened a URL or opened the file, Windows would give us this dialog that like application X wants to open this. The X was not livebook. It was like Windows script host. Like what is even that? That's the program that interprets the Visual Basic Script files. So I thought that's not great. So instead of Visual Basic Script, we went with Visual Basic, so the compiled version. We just compile, and then this dialog then said, yeah, application livebook wants to, you know, pretty sensible. Yeah, that was a bad idea, because what ended up happening is we started getting these reports like, yeah, I downloaded livebook and it's malware. There is a backdoor. And you know another one, and we thought we made we thought we were doing the right things. Like we used the Visual Basic compiler that comes with Windows, so we use the official tools, of course. But then turns out people tend to write malware in Visual Basic. That's weird. And like to be completely honest with you, that was pretty tough. Like we used the cross-platform GUI toolkits, but we found ourselves doing this per operating system workarounds, and then like it's fine that there are bugs, right? But like we have to go down deeper to fix these bugs, like in these different layers. So that was pretty tough. And then the app bundler idea, even though still I think the declarative UI was kind of cool, it wasn't really. It didn't turn out to be practical because like we hid all of the native code, then if you needed something special for your app, there wasn't really a good idea. So yeah, again, that was not fantastic. And we took a step back. And and just to be clear, I think like these cross-platform GUI toolkits like WX Erlang and WX Widgets as well, I think these are actually really fantastic pieces of technologies. And like any communications I had with the maintainers, they were just great, like super responsive, super helpful, kind. But for our use case, that didn't, that didn't work. To be fair, we have a somewhat niche use case, which is just a menu bar app, kind of hidden, so not really the usual use case. So yeah, we took a step back, and instead of using these GUI, cross-platform GUI toolkits, we decided that, yeah, we are gonna use native GUIs. And instead of app bundler project, which is like hiding all of the machinery, like abstracting everything out, we decided to have a different library which bridges the native code that you write with the Elixir code on the backend that you write as well. And we call this Elixir Kit. And so for livebook, the API is pretty much the same as we had before. We start Elixir Kit, which is just subscribing to events, and then we can publish events, and then we can handle the events that come back from the clients. And then we had clients. We actually wrote this code ourselves. So this is livebook.swift for Macs. And actually, again, like our application doesn't really have a lot of desktop footprint. So the whole file is like 150 lines of code, really manageable. And then we stuck with the platform tooling, so then we could use like Swift.build. So we used the Swift package manager structure, which really isn't made for apps. It's more for like libraries. So we kind of maybe overuse it a little bit, but yeah, we thought that was a pretty good fit. And the whole idea, though, was very different. Instead of like running away from these tools, we kind of embrace them. And I think it makes sense because if someone would be writing more complicated application, it would probably make sense to write that in Xcode or Visual for Mac or Visual Studio for Windows. So we try to embrace these tools. So we have livebook.cs or C# for Windows as well. And again, we have the .NET build. We can use the .NET build tool. In terms of the API is really straightforward. We just start ElixirKit, so subscribing to events, and you can publish events. So that's on the server side. And then on the client side, we have, again, for Swift, so starting ElixirKit. This establishes a TCP connection between the front end and the server. So they exchange messages over that connection. And yeah, we can publish events, or we can subscribe to events. And we have the same for C#. And yeah, ElixirKit lives in the Livebook project at the moment. Eventually it's going to be extracted out, but it's just easier this way. As part of the project, so we have this OTP bootstrap directory. So this is just a bunch of scripts to bootstrap OTP for Mac. So we, from scratch, built OpenSSL. We built OTP kind of tied to that OpenSSL. And we cross-compile this to both Intel Macs and Apple Silicon Macs and kind of bring this together to the so-called universal binaries. So then we have just one installer for Livebook. And there is a whole other thing that we have, which is building the installers, like patching up the apps, building the installers. That's part of ElixirKit. We have some scripts around that, so it's all reusable. As part of ElixirKit, we also have a demo project, and the demo contains like the backend code. Again, similar stuff as before. We start ElixirKit, we publish a message, type log, and then hello from Elixir. And every 1 second, we would be like, we are going to stop in X seconds. So we publish these messages, these events, and then we would stop after 5. And then, so that's the backend code of the demo. And then the demo has 4 different front ends. So we have the demo, so we have the Swift front end, so that's like the bare bones Swift. Again, we just start ElixirKit, we publish an event, hello from Swift, and then we subscribe to events, and after we got something, we would log it. We have the same thing for .NET, so that's the demo C#. Funnily enough, maybe you have heard, .NET is cross-platform-ish, so we can run this code on a Mac. I mean ish because like this code is actually going to work, but there is the Windows Forms thing that's not going to work on a Mac. It actually works on Mono, which is like this open source .NET like reimplementation, but it would, like a trivia, it would only work on macOS 10.15 because it was the last system that works with 32 bits. Yeah, so they never ported to 64. Anyway, we also have the demo for AppKit, so that's the GUI toolkit for Mac. And yeah, again, we just start ElixirKit, subscribe, publish some messages, and this is that in practice. In the log, you can see hello from AppKit, hello from Elixir. So we have the connection, we can exchange messages. Stopping in 5, stopping in 4. We log a message if a button was pressed. And we have the same demo for Windows. And yeah, I think we are pretty happy with the solution. We are confident that this is the way to go for us because you know, we can, if something, you know, we have full control basically. So if there is any like a special thing that we want to do, we can totally do that because we write the native code. There are trade-offs with that, obviously. So we have to maintain a code base per platform. Again, this trade-off totally makes sense to us. Like if you would have like a really complicated GUI, then maybe like a cross-platform GUI toolkit would make sense. But for us, we have very small footprint, so this definitely is the right trade-off for us. The other trade-off is like, great, we know we are gonna write all of this native code. Yeah, that's hard. So network concurrent programming, like for me, without prior background in these languages, was not easy. And pretty early on, I noticed, like I learned these rules. So never block the main thread, and then GUI updates needs to happen on the main thread. So we had this bug report the other day, like a while ago, that someone installed Livebook, they started it, and nothing worked, like no error, no anything. Yeah, as I was adding a feature, I blocked the main thread. So never block the main thread. And yeah, I'm basically out of time, but so some people already ask about like, what about live view native? Like, is there any overlap with what we've been doing? These projects are completely orthogonal, but I think it would be really interesting to use both of them. Because what live view native does is it uses Elixir on some backend, like on the internet to like drive the UI. But then with ElixirKit, we can actually have that backend on the device as well. So I think there could be pretty interesting opportunities in there. But yeah, that's my presentation. Thank you very much.
Cool, thank you. Amazing talk. We have a few minutes for questions before lunch. So one there. Sorry, Jonathan, can you please?
Hi, amazing talk. So not a question, but please do the Livebook Lite. I would love to have it on the iPad.
Yeah, I agree. It would be good. Yeah. Why don't you do it?
Hi, Watchdog. Thanks for the talk. I haven't seen the ElixirKit before, but are you still running it in the same process? And how do you do the communication? I'm curious about that.
At the moment we actually run in two different processes, so we don't use the embedded one. But yeah, we talk over TCP connection. It would be totally possible to do the embedded route, which would be kind of cool because then we wouldn't have to necessarily talk over TCP connection, just like use the native messaging. So that would be cool. Yeah, we ended up not using this because I think this is like, if we did the iPad app, then we would definitely go that route. But without going this route, it is more portable, so to speak, because people won't need that special OTP with the patches that you created, which we are all very thankful for, Dominic. Let's give a round of applause to Dominic.
Any more? I have to get back here. No, I guess that's it. So yeah, let's thank Wojtek again. Thank you.
Thank you.
sorry, and Federico is a software engineer at .io.
Now, and it has some great hooks in there to provide that kind of feedback. So there's constant evaluation happening in the background, which gives code insights and stuff. Like that. Yeah, thanks.
The sponsor since the beginning. That's see what this idea where the compiler works. It needs to be the live stuff enabled for stand up, and right, so that's why you can have it run not only from the and start imagining those. So that's good. Code it here. The same. Who here says right in the box here? Right, so
Broadway, Surface, or Elixir Sense. As you might also know, Phoenix Live View has a well-deserved reputation of being very efficient on the payloads that is exchanged between the client and the server, minimizing the data that's sent on the wire. But what happens when the application that you're building demands highly frequent updates? So in such cases, you might need to know deeper details on the implementation, and yeah, in this talk, Marlos will explore Phoenix Live View's diff tracking and other stuff, and yeah, welcome Marlos to the stage.
So I'm here today to talk about optimizing Live View, and I think the title could be a little bit misleading because what we are actually trying to do here is optimize the applications we build using Live View to make it work the best way. It's already highly. I don't want to give the impression that I'm optimizing Live View itself. So the first question we should ask is always, should I really care about it? After all, we don't want to do optimizations unless we need it. So I would say that most of the time when you use Live View, especially because it is already highly optimized, the answer is no. You usually don't need for most small applications, you're not going to need anything. You don't have to worry about this. However, if you have applications that have pages that are highly frequent updated, for instance, because you're subscribing to a bunch of pub/sub topics, or maybe the size of the payload on each of those updates, it's large. Or maybe there might be some of the users with slow connection, or even all of them. So you probably should care about optimizing your application. So before we jump into some of the examples, it's important to keep in mind two important concepts in Live View, which are chain tracking of component assigns and diff tracking of templates, because those are going to be the backbones of most of the optimizations we're going to be able to do. So this is a very high-level overview of the process. There's much more going on, but for this presentation, we're going to assume that this is what's done by Live View. So the first thing, Live View is going to split the templates you create for your components or Live Views into static and dynamic parts. So whenever you use a component, instead of the component returning just a string, it's going to actually return data structure. And this data structure is going to hold the static and the dynamic parts along with other information separately. And Live View also going to try to send, not going to try, in the first one, after it gets the connection from the WebSocket, it's going to send all that information, the static and the dynamic part, to the browser. So it's also going to keep track of changes of the components. So every assign that changes, those changes are going to get tracked by Live View. And in case there are changes in those assigns, it will try to update only the dynamic parts of the template, only the parts that are related to those changes. So it's a very optimized process. This is going to be applied in the whole template, including the child components. So tracking changes of assigns, if you're using live components as well as live views, it's kind of easy to track the assigns because the state is kept on the server. So in order to check if there are changes, you just need to compare the new state with the old state. For function components that are stateless, it's a bit different because since we don't have the state, Live View has a special assign, the changed assigns, that will keep track of all those changes. Okay, so, and stateless components in Live View, they are pure functions. So as pure functions, they use the same optimization. The pure function, if you pass the same argument, it's going to generate, if you always pass the same argument, it's going to generate the same result. So in a function component, a stateless component, it's the same thing. If you pass the same values of all the attributes, it's going to generate the same, it's going to render the same thing. So if nothing has changed, it doesn't need to be updated on a browser. Not sure if it's clear enough there, but just to have a visual representation of this. So this template is going to be split. Like the first chunk is going to be static. There is no dynamic information there. And as soon as it gets the curly, in this case, the template is a surface template, but if it's a live view, it would be the equivalent, which would be that, I don't know if there's a special name, but it's like lower than, percentage, equals, and it's going to be the same thing. Then the dynamic part, and then the other part is static again. So everything is going to be split, and after it gets the connection, it's going to send all those parts. So we can take a look at the demo here just to make sure get this. So if we go to the console, you're going to have the first rendering. Yep. And as you can see, you're going to have all the parts. You're going to have the dynamic part here. I'm not sure if it's big enough. Is it okay? Okay. So from the second one, if I keep clicking in the counter, you're going to see that only this piece of the template is going to be updated, because that's the only thing that changed. So given that information, we're going to try to set a few goals in order to optimize based on those information we have and how live view works. So the first one would be to minimize the dynamic parts, because as you've seen, the static parts are all sent once, and then they're not sent anymore. So all the information that are going to be resent on each update is going to be the dynamic update, the dynamic parts. So if you minimize the dynamic parts, you're going to get some optimization. So one way to do this is to use components instead of function calls. Using function calls was something really common before live view. And if you're converting a template, an old template to a new one, be careful with those functions, because as I said, a function returns a string. A string cannot be diff-tracked by live view. So if you convert it to a component, it will be able to track the static parts. So we have this example. It's basically the same example, but whenever I click the button, I'm actually bringing a message. If you take a look at the code, so I'm using a function here. So whenever the count gets incremented, since this is a function, the whole thing is going to be sent to the browser again, even though this part hasn't changed at all. So you can optimize this. If you translate this, and instead of using the function, you're using a function component, you see now that we're using the sigil F. If it's not live view, you'll be using the age, the sigil age. So if you compare now with the optimized version, you're going to see that now only the dynamic part it's coming to the browser. So this is huge, especially if you're translating old scripts into new ones that used to have, because if you're just using controllers, if you're using this in control, it's not a big problem because it's going to send the request only once. But if you're using live view, this might be critical. Another way to minimize those dynamics parts is to use CSS state, area, or data selectors instead of functions. So a common code we have in many tutorials is like using a function to generate classes. There are libraries doing this. You probably have this somewhere. And this gets the same problem as the example before. So I have this example that I can enable and disable. The button, if I click on the checkbox, and as you can see, every time I click the checkbox, all the classes are coming to the browser. So what you can do is, instead of using the function to calculate the classes, you can use the disable attribute itself, okay? And then instead of having to inject dynamic code here, we're only going to have this piece of code, which is dynamically, and all the rest is going to be in the CSS, which is static, and it's going to be bundled in the application. It's going to be loaded first time. So this is a very nice trick, and it can save a lot of the payload, especially if you're using Tailwind, when you can have components with dozens of classes. And if you have these components with hundreds of classes inside of for comprehension, presenting hundreds of components, it can get messy. If you're using Tailwind, you can also use the variants. Tailwind comes with some default variants, including disabled. So you can use this strategy as well. The first strategy is not limited to Tailwind. You can use whatever CSS technology you want. But if you're using Tailwind, you can also use the variants. So instead of creating a class and having the state disabled to get different styles, you can directly use the variant here, and then it's going to be all static, but then it's going to be conditional to the value of the disabled attribute. Another similar case is when you have conditionals. It's common when you have a component, and the component has some kind of state, and a bunch of things in your component, including child components, child elements, has to display differently according to that state. Okay, so we have an example here, which is a toast, and a toast could be a warning, it could be an arrow. So if you change the arrow, if you change the style, it's going to change. And as you can see here, the payload, whenever I change this, it's bringing a bunch of classes. The same thing as before, because if you take a look at the code, we have a dynamic expression here. And the goal right now is to minimize those dynamic parts, because they are resent to the browser whenever the component needs to be re-rendered. So what you can do here, it's instead of creating those, injecting those conditionals all over the place, you can have a single condition, a single expression, which you can use the data. In this case, it will be the data kind. And that's the only dynamic part you're going to have in the component. Because all the other conditionals is going to be declarative. They're not going to be, instead of being here in the code, in live view, they're going to be in the CSS. So you're going to have the basic things you have for the toast, but then if the kind is warning, you're going to be, have a yellow background and whatever else you need. If it's arrow, you're going to have this. So you translate this dynamic part to a static part. And this works great if you have components that are going to be used inside for comprehensions and going to be rendered hundreds of times. For context, everything that we're seeing here is actually things that we face at SimpleBet, because some of our applications, they need to keep information updated real time during the events. So at some of the pages have more than 1,000 of many of the components, and they update many times per second. So we kind of have to face all those issues and tackle one by one. The same way as before, if you use, that solution is generic. You don't need Tailwind to do it. You can do it with plain CSS. But in case you're using Tailwind, another nice way to do it, it's also to use variants. But in this case, it's going to be arbitrary variants. I think this was released in the latest Tailwind version. So you can actually, instead of adding this to the CSS file, you can add it inline in the class. So you can say data kind equals arrow, and then you have the style. So this is always static. So there's going to be no conditional here. So no expression is going to be evaluated. Only the single one in the top of the component. And one of the things that I think this is really nice, it's, you can even, with Tailwind, you can even use the group syntax, which you can have like at the root of the component, you're gonna say that is a group, and then you can, every children that needs to depend on that group, you can also have the variant, the select. So it's gonna be a variant based on an information about a node in a parent node. So the second goal we have is to minimize re-rendering, because in function components, since we don't have the state on the server, we don't know, we always need to count on the changes that can be evaluated. So whenever there's a change in an attribute, it needs to be re-rendered, which means that the static part is not going to be resended, but the dynamic parts are going to be resended even if they haven't changed, okay? So one way to avoid re-rendering of components is to pass only what the component needs. So we have a small demo here that is really basic. We have a user, like to simulate some kind of act model, first name, last name, and the updated at. And we use a function component and pass the whole user. This is pretty common, and this is totally okay. Because you're usually going to have this information, you're going to show it in a profile component. You're not going to update this a lot of times. But you have a different case when you have to update this many times per second. And this is going to be in a for comprehension, thousands of components. You're going to see that here's the first rendering. And every time I update the updated at, which is here, the name is sent again. So even though it hasn't changed, it's going to be sent again on every request. And it might be a lot of stuff, depending on your case. So what you can do here, in this case, which I mean, for user, for most of the case, I don't recommend. I think it's totally fine to pass larger data structures. But for this case, understanding how LiveView works, you need to know that if you pass this to a function component, even if the function component doesn't use one of the fields and the field changes, it's gonna re-render that component again. Not the static parts, but the dynamic parts we're gonna be resend. So if you change this and pass the specific information you need, so the first name and the last name, instead of the whole user. So the same example now, whenever you click update, it's not going to resend the name. Okay, so it's going to change the updated at, but it's not going to resend the name. Another thing you can do is to set, if you have computed values, like it's pretty common, and again, it's totally fine if it's a simple example, it's a simple case, but sometimes you have information that is generated from other information. You have attributes passed to the component, and then you're gonna get that information, gonna calculate some other information, and gonna render. It's common to create a function, and then receive that information, calculates inline. So, like this one. So this example is the same counter, but this time I have a message that whenever the counter is multiple of 5, it's going to change the color. Okay? So if you take a look at the payload, you can see that even for this component, even when it doesn't change the color is going to be resend. So you can see here, gray, 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 gray. And it should because it hasn't changed. But since the implementation is a conditional here, and you're using count in that conditional, so LiveView checks the expression. Is there anything that changed in that expression? Yes, then it needs to re-render that code. So in this case, since we're calling a function and the count has changed, even though the result of the function hasn't changed, it's going to be re-rendered. So we can fix this by actually, instead of using the function inline in the template, we can actually create a new data, a new assign, and that assign is going to be updated separately, not inline in the template, but it's going to be calculated and then going to be set in the socket assigns. So in this case, now, it's different because now, if the function returns the same value, the assign is not going to change. If the assign doesn't change, it doesn't need to re-render. So if you go to the optimized version, you see that now only when it changes, it's going to send. So whenever it doesn't change, it's going to keep it. And then when it changes, it's going to send just what it sent. So this is a trick that might be important depending on the case. Be aware that whenever you're using functions inside the templates, it's always a red flag. It might be fine for simple cases, but you never know when you're going to reuse that component. Sometimes you use a component, you're going to just place it once in a page, but then somebody can use that component, and then it's going to have like thousands of instances. So if you want to avoid this, try not to use functions inside the template that calculates values. Calculate the value, set an assign specific for that, and go with the assign. And the last goal we have to get even better optimizations is not directly related to what we've seen so far, but at the end it's going to be, because we need to, even if you do all those optimizations, that might be the case that your live view just receives too many messages, like pub/sub messages, and you are updating the socket on every message that comes. So this is common, and the tricky part is that usually if you do this in development, you're never going to notice, because, I mean, even if you try to send thousands of messages per second, you're locally, so it's going to be fast. And Phoenix is amazing. I mean, it spoils us in a way that you just think it's going to work like this in production. And so there are two ways to handle this. The one is to minimize the number of messages. Don't send too many messages. That updates the socket. That should be like the goal number one, because you need to understand that a user will not realize changes in less than 100 milliseconds or so. So there's no point in sending information to the browser on every millisecond, because it's not going to be noticeable to the user. And there's nothing that protects us doing this in Phoenix. You're just going to have a topic, you subscribe to a topic, you're going to receive messages, you're going to update the socket. Locally, it's going to be really fun. But if you go to production, what might happen is that if a user has a slow connection, things can get really messy. So this is a small demo. And for this demo, I'm simulating a pub/sub here. So I created a Gen server, and the Gen server sends one message for each millisecond, and then I update those 40 texts, okay? And locally, it's going to be probably fine. Oh, sorry, spoiler. Here we go. So that's Phoenix. I was kind of okay. That's Phoenix, okay? 1 millisecond, you can update 40, even more, you can 100, even 1,000, I don't know. It's really fast. And if you take a look at the observer, I don't know if I can. If you take a look here, you see there's nothing unusual there. No memory consumption out of the normal. So what you're going to do now is try to simulate a user with a slow connection. So the first thing you notice is that visually it gets pretty much slower, but that's okay. I mean, it's a slower connection. You could expect that. But that's not the worst part. The worst part is that if you come to Observer now, you're going to see there is a process that is starting to accumulate messages in the queue. And this is going to grow unbound, because it's not going to keep up with the number of messages, and it's going to keep accumulating those messages. And the memory is going to explode. The live view is going to crash, which is the best case scenario. Worst case scenario, if you have many users, it's going to consume all the memory, the VM can, and so this is tricky. I mean, from all the cases we've seen so far, I think this is the trickiest one because it's probably going to happen in production because you usually don't test these kind of things for slow connections. And this is fine when the only person that actually has a problem is the user, the single user. But in this case, as you can see, as it consumes resources in the server, the side effect can be much larger. So what can we do in order to fix this is to batch the messages, okay? So instead of just receiving everything you have from PubSub and updating the socket, because it works locally and Phoenix is great, just batch the messages. In this case, I created a batcher that you can use as a hook. So if you have a batcher, you can say the maximum number of messages is going to batch and a timeout. So if you don't receive that number of messages, in the timeout, it's going to send anyway. Okay, so it's the same code, and you can see the difference is minimal. So this is the original one. It's the handle info getting all the messages and updating the socket. And the other one, it's basically the same thing, but now it has a handle batch, and it's going to reduce over the socket before sending the socket, before informing LiveView that you're ready with the socket. Okay, don't send any updates right now. Let me reduce all those results into the socket. Many of those changes could be applied, and then maybe another change can actually undo that change. So what matters is going to be what happens after the end of the list. So with this simple strategy, you can use the same example. No spoilers this time. So this is like the same as normal. And then if you simulate this low connection, you don't even notice visually. Because actually, instead of sending all that information per millisecond, it's holding, keeping its time, and then sending everything as batches. So it has only one update instead of 100 updates. So visually, you have the benefit that is a way better experience for the user. And if you take a look at Observer, you're going to see that it backs to normal. So I think this is the trickiest one, and that's the one that you probably need to be more careful. If you have this kind of system, real-time system, receiving bunches of messages and updating the socket. So there are other opportunities for optimization, including some new stuff, but I don't want to spoil Chris' presentation. So he's going to be responsible, I think, for introducing this. But since we're on a topic, I'm just going to mention it because they're already there. So the new JS exec function, it's really nice because if you have the same case when you have a bunch of elements calling JS functions that generates JavaScript, even if they call the same function, the same thing, everything, they're going to duplicate that code. So if you have hundreds of components, you're going to have all that duplicated. And some of those codes can be a little bit large. With the JS exec, you can have a unique place to have that code, and you just call the JS exec in all those other places. So you're going to save some payload. You have also the new icon core component. If you generate with the new Phoenix 1.7, that instead of injecting the whole SVG, which is bad for live view, because if you want to change that, it's going to change it again, the whole picture, the whole image. It's going to create classes, and the only thing that changes if you are dynamically changing that image is only going to change the name of the class instead of the whole SVG. The SVG is going to be sent previously as CSS. And the new support for streams, if you want to save memory on a server, is going to be great, because if you have lists and if you want to show that list, and you don't need to keep that list on a server to do anything with the whole list, you can use the stream to add and remove items from the list. So you don't have to keep the whole list on a server. So I'm pretty sure Chris is going to go deeper on those. So that's what I have for you. And as I said, you're probably not going to need this all the time for all the applications. You don't have to implement all of those techniques. But pay attention that, especially when you're using for comprehensions, rendering too many instances of the same component, it's important to know how things work under the hood, so you can, if needed, you can use one of those techniques. Some of them are actually best practice, in my opinion, and some others should only be done when needed. Thank you.
Cool. So yeah, thank you. We only have time for one question. So yeah, go ahead.
Yeah, my question is, so when you were showing that example and you were throttling your connection to like a slow 3G connection, that could be used intentionally if I want to ruin the server, right? So you should do it all the time. Because as a...
Are you testing? You should keep it always throttling the...
No. What I mean is you should always do what you did with the batching, because a malicious user could otherwise intentionally try to crash your server and slow it down for everyone else. Open a few connections on very slow bandwidth, and then you're screwed.
Probably. I mean, I don't know if there is another way to prevent that. And in our case, most of the applications are, we have a limited number of users, so it's not unbound. The number of users is not unbound, and they are kind of trusted users. Okay, so I mean, you always be. I mean, I think you should always try to do this, but only if you have this kind of implementation. Like you're gonna render a bunch of things. If you're gonna render, I don't know, one piece of information here, another there, and you're gonna update after a minute or so, I don't think you should bother doing that. But whenever you have, especially PubSub, if you're using PubSub, be careful, because you can have that kind of problem.
Cool, thank you. So yeah, let's thank Marlos again for this great talk. Hey everyone, welcome back. Hey, so yeah, welcome back. We're starting off our next talk. Hey everyone, I know there's a lot to discuss, but yeah, let's focus. Welcome back. So we're starting our next talk. I have the privilege of introducing Evadne Wu to the stage. So she's a very active member in the Elixir community, having created open source libraries such as ETSO or Pacmatic, but also having given a number of talks on previous editions of ElixirConf, Elixir London, and also the Erlang Elixir and Friends Dev Room at FOSDEM that I helped organize a few years ago. So yeah, shout out to that. If you've seen the TV show Silicon Valley, then you probably know and remember the time that Jin Yang built a not hot dog machine learning application, which then became a meme. In this talk, Evadne will explore this meme as a way to show the power of the Elixir ecosystem in the machine learning space and how to build an end-to-end solution with conventional technology. So yeah, let's welcome Evadne to the stage.
Hello. So everybody, thank you for coming today. It's been a great honor. So I found out it's not a 1 hour talk, but only 35 minutes or 30 minutes. So I will make it quick. So about me, basically, sometimes I write software, sometimes I don't. I created some packages, but today it's all about memes. So yesterday before the flight, I opened Stable Diffusion. I asked it, what would today's session be like? And I got this from Stable Diffusion. I think hopefully I surpassed this expectation. So first of all, the problem. What exactly is the problem? You probably have seen this meme before. This is basically not hot dog, where the app on your phone allows you to look at a piece of food and it tells you if it's hot dog or not hot dog. Apparently, it's still being used at the moment. So somebody would say, I recommend if world food can be very confusing. Spoken like a true Android user, for sure. Somebody would say, this app is a must-have. I use it 5 to 10 times a day. Highly surprising. But the problem is, sometimes it's useful but not entirely accurate. Okay, so assuming that this meme has been around for a few years and the world of Elixir has advanced greatly, are we able to create a new version of this application which surpasses the original capabilities? I think yes. So first of all, obviously, we need to deconstruct what exactly is the application of hot dog. And the algorithm is as follows. Basically, when I'm using my phone and I look at a hot dog, it produces a video stream of the hot dog and then sends it to a web server. The web server makes a decision based on the content of the stream and sends the result back to the application. See, it's basically Elixir, but Elixir with a little bit of help from the friends. So now we can get started. Okay, so the most important thing is actually, in this case, not about the model, but about media acquisition and actually making sure your media is correct. I will explain. First of all, you need to actually find a camera. Now, why is it a problem? Because you can always use JavaScript, right? There's an API in JavaScript. It's called Media Capture and Streams API. So essentially what you do is you start, and then you look at all the devices. First of all, before you're asking the user. First you actually find out whether there's a chance of having a camera at all. And then you ask user, hey, I want to use your cameras. Okay. And then you start enumerating the cameras with a tight constraint before you do it again with a loose constraint. Why tight? Why loose? Well, in a tight constraint, you can say, I want a camera to have a certain kind of output. I want it to be the frame to at least be this big. But most importantly, I want it to be the back camera on the phone. If there's no such camera, then you loosen it and you remove the constraint. This is very important because when you do WebRTC, especially on phones, with multiple cameras, if you don't specify anything, you get the user camera, which is in the front. It will be very inconvenient. So you must try to get the right camera. Now, assuming you have the good camera, Now you need to start doing the bulk of this talk, which is you need to basically grab the video stream and then send it to web server. So at a very, very high level, the outline is like this. First, you do a handshake over WebRTC, and then you send a stream by using Phoenix, LiveView, and using Membrane. Now, for those who are not familiar in emoji, the equivalent is here. Basically, first you get a browser, and then you acquire the camera. Once acquired, tell the LiveView, I now have the stream, you can do your job. LiveView starts an inference session, which is exactly like a room, but with only one peer. If a second peer comes in, the peer is rejected for simplicity. And then the LiveView tells Membrane, hey, start accepting my WebRTC traffic, give me the information, and then sends all the info back to the browser. In the browser, I have a hook in LiveView, and it will call out to the Membrane SDK and start the handshake, called ICE, Interactive Connectivity Establishment. So at a high level, now you have this. You now have the stream that's on the server. Now, on the server, you need to decide whether the incoming stream contains a hot dog or not. So again, break down the problem, two parts. First part, you need to actually get individual frames from the stream, because the incoming stream is a video stream. It's not a bunch of images. It's compressed. So you need to decompress and get the frames. And then you need to send a frame through the model in the correct format, so you can actually make a decision. So what do you do? Again, first thing, you need to look at the frames. Remember, we have Membrane. So it looks like this, right? So when you start the session, WebRTC engine starts, and Membrane gives the track to my own endpoint, which I add next to the WebRTC endpoint. And that endpoint does the job. So the important thing now is what's inside the endpoint. And if you were to zoom in, it's like this. It's a chain, basically a chain of things that you do. So basically, first, get a track, and then depayload, because the track is basically data. You need to make sure it's rearranged in order, because it's UDP. It can arrive out of order. So you need to depayload, sort the packets, and then you need to find out the orientation of the incoming stream. I'll explain why. And then you parse the stream, and then grab the individual frames. So why do we need orientation again? Well, if you have ever used nerves, you're lucky. Because when you take a camera and you point at something, it's always upright. Because if not, then you go back and you turn the camera. But this is the problem. If you notice, when you take a phone and you aim it at something, and the phone is in portrait, the camera actually isn't upright. So you must know the orientation so you can correct it. There's a second problem. Neural networks are trained, and they respond based on their training. So let's say, oh, I have a lovely image of penguins. Okay. But if I send it in upside down, okay, now I have a lovely image of surfboards. So this is actually a problem that either you correct it by training more, or you make sure your data is correct. Now let's say, oh, I have a lovely model. It takes 640 by 640. Okay. Now I have an image of more surfboards. So you must make sure your input is correct. Otherwise, it wouldn't work. So fortunately, in WebRTC, the orientation of the video is described in a header extension. So this is the packet, as shown on Wikipedia. In the packet, there is a place where they put extensions. And there is an extension that shows you the orientation of the video, and also if it's flipped. Okay, so look at the 2 bits, and then you know what to do. So it's important. Now, you have the orientation data, so now you go down and you start your inference. So, well, you have the frame, and you have the size. Why? Again, because compression. So you will need to know, one, how large is the frame nominally, and also you need to have the data. And then the sync will then request inference. So why? Well, the answer is, sometimes maybe my GPU is too slow. So I can say, well, the frames can come in 24 frames a second, but I can only do 10. So I need a requester. I would tell the requester, hey, here's a new frame, here's a new frame. But it would drop frames for me, drop the load, until another frame can be processed. Because in live video inference, in this particular use case, I don't care if a frame is late. If it's late, I don't want to see it. It doesn't help me. I want to just infer the latest frame available. So this is a key difference here. All right, so how do we actually manage the inference process? I will apologize because I thought of this talk last year, exactly 1 week before this serving component came out. So I did it without serving, but I added it later. So currently, there's a version of a broker, which is a two-sided market. And when I say two-sided market, you would think, okay, it's fish cake sets as broker. You will be correct. So on one hand, I have a queue, ask. Every client has asks, and every daemon, in this case a GPU, a CPU, has ask R or bid. So, well, they can come in, and the broker would tell the incoming processes, hey, your frame cannot be processed by something held by this PID. Yeah. And the queue will drop load for me. So now, at least we know how to get individual frames. Now, here's the other problem. Getting the frames formatted correctly so I can actually do inference. So what exactly is in the inference process? Well, again, the outline is pretty simple. You have a frame, you munge it, and then now you have a tensor. Now you run it through the model, you get output tensor, and you munge it again. So input conversion, again, very, very important. Why? Usually when you look at an image, it's RGB. What is RGB exactly? It's, first, it's width height channel, it's three-dimensional thing. But it's stored memory like this on the right. But when we use live video, we don't just send raw RGB, we send something that's more compressed. And this is the frame, YUV. It's Luma and Chroma. So it's like this. So as you can see, it uses less memory, about half, and while losing less resolution. So this is what we usually get. And we need to convert it, however, to usually, in this case, in my model, convert it to planar RGB. Anyway, so I need to do this. And then I can run the model. So another thing that I do is depending on the nature of the model. Let's say post-processing. Why? Because, well, there's a key difference between image classification and object detection. So when you do image classification, it's basically, okay, so for everything in this image, what is it? And for object detection, it is find individual objects in the image and tell me where these objects are, and also your confidence level. So for this demo, I have elected to use object detection, but here's a problem. The boxes of detections may overlap. So we need to have some post-processing to clean up. So this is basically just apply some kind of post-processing. So again, for this case, I will use the very beloved and simple solution of C++. Okay, and I will use a model which tells me what objects are in frame. I will use such a simple model called YOLO v5. Again, you only look once. On the right is the model network. All right, why? Because YOLO v5 is pre-trained. It's trained on 80 classes, and one of the classes is hot dog. So I'll just write my API. I say, tell me about all of your detections, and then I match on hot dog, and I have my decision. Okay? So how do I actually write the front end? Again, Phoenix. So with Phoenix Live View, just I put a video, and I put SVG, and a rec, and a text, and the DMV, just basically lay out the user interface. So it wouldn't be much of a talk if the result isn't seen. So let's try a live demo. Okay, that would be perfect. So one additional thing that you may notice is that when I zoom in on one hot dog, I can see the hot dogs. But when I zoom out, sometimes no, because it's due to a lack of resolution. But usually it will stabilize after a while. So yeah, if I were to just do it with image classification, then what I found was it would be okay if I just have one hot dog in the frame. But once I have like 3 or 4 together, it tells you, oh, I'm looking at a menu. So this was why I decided not to do image classification, but instead to do object detection. Okay. So I'll dive into the solution a little bit, but as you can see, it's basically quite responsive, I hope. So it's going through a WireGuard tunnel to my workstation in London. Latency is probably 40 milliseconds, and frames that are late are dropped, otherwise detections are returned. So all of this is basically all drawn by SVG. And why is SVG good? It's because, well, notice the center square. It's actually a square with a coordinate system of 640 by 640. So I put it in SVG, and then I wrap it in another SVG, and to that SVG, your content is 640 by 640, but scale to however big you are, or however small you are. This is a beautiful way of doing it. Like, absolutely beautiful way of doing it for a web application. It doesn't require a lot of thinking. And more importantly, you can do CSS on your element. So I can say, if I detect a hot dog, then the box should be green, and so on. All right, so the solution works, okay? Now let's see. Okay, so now the thing is, the talk was developed like a while ago before the membrane framework was 0.17, and before NX serving was created. It was called Axon serving at the time. So, however, then Bumblebee came out. So, can we do it simply with Bumblebee? Well, I was browsing the internet and I found this. Okay, so and then I found there is Bumblebee Vision. So, very well-defined API. So can I do Bumblebee? Can I do image classification with Bumblebee with my application? Well, the problems look solvable, so yes, of course. I would now do another demo, but this time running on CPU. So I do apologize slightly because, sorry, just leave it on the ground. I will look at it later. So the low-cost setup of this kind of infrastructure actually is a little bit more complicated because just of the way that this thing is being used and being built. I will explain. We use membrane to capture traffic, but membrane is essentially a SFU server. Membrane is actually an SFU server, so it's got internal stun and turn built in. So I need to tell membrane that there's a certain IP it should give out. Not yet. Mirroring is having problems. Okay. So I need to actually say, find my IP first. Where's my IP? 10.109.03a. And then, of course, in my inference sync, I will say, instead of doing YOLO, I will use a different OTP application, which has Bumblebee in it. And then, what I will need to do is, hopefully, it's the wrong application. Let's see. It's recompiling everything. Let's see. Inference running, and I see this, which is good. This is part of ExLA, which means that something is running definitely. So let's see, if I were to hit Emporium CPU, okay, I am asked if I want to do a handshake. Is unused. I know why. WebRTC doesn't work without TLS. TLS is required for WebRTC to make it in a secure context. So if you don't have HTTPS, it doesn't work. Now, address is not available. So as you can see, the 172.20.10.4 is not the correct IP. Yeah. So now change IP and do it again. Okay, it's telling me it's not a hot dog, and so for image classification purposes, essentially the frame has to be filled. Is it actually working? It is. It's running stuff, yeah? It's better to just move. So, okay, so now the most critical part of the demo is over. Now let's look at the code. Okay, so just from the volume of code used to do image classification versus object detection, you can see Bumblebee is much better. Because here is the application for using Bumblebee. It's got 3 files, and here's the application for using YOLO, which has got more files. So Bumblebee is better. I make a module-based index serving implementation, and basically start by loading the model. So I load a ResNet 50, and I load a featureizer, and I produce the compute, and I tell it, okay, only 1 batch because I want my result immediately, and then start link. Now when I perform the detection, I just say, okay, eVision, you have a matte converted to an image, and put it on the correct backend, and get the results. And the results are basically predictions, because there is some formatting, post-processing already done in Bumblebee. So it's very nice. I don't have to do anything. It just gives me the right results. And then, obviously, there is something called syntactically incorrect classifications, has hot dog. Basically, if any of the classifications has a label that includes the word hot dog, then the flag is set based on the classification. So I integrated both paths into the live view. Yeah, so basically that's it. How are we doing on time? Okay, so I think now let me take any questions from the floor.
Cool, yeah.
Any questions?
Mind-blowing live demo, very brave.
It blew my mind that it actually worked. I didn't expect it to work.
Any questions? Yeah, I think everyone's just mind-blown, yeah. Oh, sorry, yeah. Oh.
This was great. Thank you so much. That was mind-blowing, really. But on the WebRTC to transport the video, is there other ways to transport the video over there? Like, could you not make like a, I don't know, like a WebSocket data stream or something? It seemed like that made everything more complex because you needed the turn server in that.
Yes, there is a way. Yes, you have to write your own transport, which my small brain is not capable of. WebRTC transportation uses UDP, so it's more efficient. It handles frame compression by using a video format, and you send like half or less than half of the information than RGB, so it's more efficient. And membrane is already built. So I decided to use it. But yes, other solutions exist, such as, because we're using JavaScript to acquire the camera, you can do your computation on the frame to basically compress it yourself, somehow use the JavaScript and then send it to the backend, but you will have to do it over WebSockets. I think you will not be able to use UDP at all without using WebRTC, but I may be wrong. Because if you want to be able to run like 20, 30 frames a second, it's probably worth the effort.
Oh, one more there. So have you tried putting hamburger on it to see if we satisfy that user?
Sorry?
Have you tried with a hamburger? Because we saw that one of the users was complaining about the other application that... No, yeah.
I don't know. I think ham will require time, but I can. May I interest you in perhaps a banana detection system?
No. But I was asking if you had any trouble with misidentification of the hot dog with a hamburger or any other item. Like one of the users was complaining on the reviews of the application.
Yeah. So the thing is, it's an Android application.
Okay.
I think there is an iPhone application, but it does it based on uploading a static image, so it takes multiple seconds. It's not good demo material. There's a question in the back over here.
Where? Oh.
Sorry. Can you pass? Thank you.
What challenges did you encounter when using Membrane?
I would prefer to say these were all overcome actually at the end. In fact, I need to give special thanks to the Membrane team members, 2 of them. I think they might be here. And I need to give special thanks to Coco because I pestered these 3 individuals with endless questions over the past year. And eventually I got all my answers. So for Membrane, it is a highly dynamic framework, highly dynamic, highly evolved. If you want the performance, then there is no other option, in my opinion. It's like, the code, the lines of code, especially in live media, I think sometimes it's written in sweat, maybe in blood sometimes. It's better to just not learn it. Any further questions? This one in the back.
Yeah.
So, how many hot dogs did you go through during testing? Because I figure you have to do it the same way you do the demo, right? You just had to have a big supply of hot dogs to work through.
Yes, so I cheated. I used Google image search, and I look at 100 of them at a time.
I don't think that's real TDD.
No, so fine. Yeah, the thing is, the reason why the model was chosen was because hot dog was pre-trained. It's a popular image classification category. It exists in Coco 2017 and earlier. Otherwise I would say, not banana.
Cool. Yeah. So let's give a big round of applause to Evgeny. Yeah.
Go!
the creator of Livebook, and Kino, also the co-creator of Bumblebee. And he also wrote the Elixir grammar for 3-seater, which makes our code in GitHub look much better. So yeah, he's not only doing that, but also he's very supportive. And I speak from personal experience, like when I was trying out the Whisper speech-to-text using Bumblebee, and I was just using the master branch at the time, and Jonathan was very helpful. So both I and the community are very grateful for his work. And yeah, in his talk, Jonathan will show how Bumblebee is building a streamlined machine learning experience in Elixir. So yeah, let's welcome Jonathan to the stage.
So, hello everyone. My name is Jonathan. I work at Dashbit, and today I want to show you how you can build machine learning-based features into your application and a new project called Bumblebee. So, to put this whole talk into some kind of context, let's imagine we are building an application, and we want to build features which roughly translate to function calls like this, right? So, just to name a few examples. Maybe we want to classify whether a user review or comment is positive, or maybe it has harmful content. Maybe we need to transcribe user voice messages, like something with images classification, or like object detections, any of those things. And if we were to go like back and do those kind of things in Elixir, we would basically need to go to a different technology, all right? But 2 years ago, we started this effort of numerical Elixir, which brought a couple new tools into the ecosystem. And specifically, there are 2 tools related to those objectives that we've just said. And the first of them is numerical Elixir, which basically allows for very efficient numerical computation to happen in Elixir. And in particular, it allows a subset of Elixir to run on the GPU or on a CPU in a highly optimized manner. All right? And then there is a second project called Axon, which allows us to build and train neural network models. All right? And neural network models are relevant because if we go back to our objectives, those kind of functions are generally hard to implement by hand. So instead, we usually turn to machine learning, all right? And specifically to neural networks. So with those new tools in the ecosystem, technically we can build any neural network, you know, and do those things. But there are still some challenges. Building a neural network requires a fair amount of expertise. To train the neural network, we need compute resources, time, and most likely a lot of data, right? Because that's how the machine learning generally, that's what the machine learning relies on. So the question is, do we need to go through all of those hoops by ourselves? Or maybe there is something that we can do to make it easier. And the answer is we can use pre-trained machine learning models. And to make sense of it, there is a very important piece to this whole story, which is a platform called Hugging Face. And this is literally the logo of the company. And if you go over to Hugging Face, you can see, like, you may get some GitHub vibes, all right? And the easiest way to describe Hugging Face is exactly GitHub for the machine learning community. So if we go to this models section over here, I'm just going to zoom in a little bit, we can find a lot of Git repositories with machine learning models, all right? So let's have a look at one of those. As with any open source project, we can see like a README describing what it does, and we can also see a quick demo of what this specific model is doing, right? So in this case, you can see it deals with text data, and it tries to predict a missing word, which we denote with this mask word, right? And now if we go to this files section over here, this is just a regular Git repository, and the interesting part is that we have a number of those fairly large binary files. And those files are exactly the trained parameters of this given neural network. So in other words, someone else implemented a neural network, they trained it using a lot of data, and they uploaded it to this repository to be available publicly. Right? So wouldn't it be nice if we could just take this model and load it straight into Elixir? And this is exactly what the Bumblebee project does. So if we copy the repository name and go back to Livebook, in this notebook, I have the Bumblebee package listed as a regular dependency. All right. And now if we go back here, in the Bumblebee module, we have this like load model function, which expects some place where it should load the model from. So we want to say load from Hugging Face from this specific place. Let's run this. And this is going to give us some data, right? So the first thing is that we have an axon struct, which is this whole neural network built in Elixir for us, so we don't need to do it ourselves. And then we also have this map of parameters, all right, a lot of numbers. And those are the parameters that someone else took and trained and uploaded so that we can load it. Okay? And there is one more thing about neural networks, which is that they generally work with numbers, right? But as we could have seen on the Hugging Face example, this particular model is supposed to handle text. So how do we bridge this gap between text and numbers? And the thing in between is what we call a tokenizer, which is exactly this like algorithm for processing text into numbers. And we can load a tokenizer from the same Hugging Face repository, right? So in the Bumblebee module, we have a load tokenizer function. We pass the same name, and it's going to return our tokenizer. Okay, there we go. We can also match on this, because this will be useful for us. Okay, and now that we have those two things, there is one part missing, which is how do we actually make use of it, right? Like how do we stitch them together? And other than allowing us for loading those models, Bumblebee also has this idea of like end-to-end processing pipelines, right? So in this case, as we could have seen with the demo, this model fills a missing word in a sentence. And in the Bumblebee text module, we have this fill mask function, which is going to be like the pipeline for us. And conveniently, it expects the model and the tokenizer. And what this function is going to return is what we call serving. So serving is exactly this end-to-end pipeline where we should be able to like throw text. It's going to apply the tokenizer, run the neural network, do post-processing, and give us hopefully some structured information that we can make use of. And to see how it works, we can now just run run the pipeline with nx serving run, passing the serving and some sort of sentence. So let's say the capital of Portugal is whatever, and we expect the model to guess what it is. There we go. We have this nice list of predictions, and each prediction has a score which corresponds to the certainty of, how accurate it is according to the model. Cool, so far so good. We've got 4 lines of code and already did some machine learning work in Elixir. So now the question is, how do we know which model is compatible with which task, and like do we need a tokenizer, or maybe we need to log something else? And this is where Livebook is going to be very helpful, because we have the idea of smart cells, which you could have seen on Jose keynote this morning. And we have this nice neural network smart cell with all of those different tasks, right? So let's try image to text. If we run this, we're going to get this nice form. Can upload an image, a picture from Lisbon. And the first time it runs, it's going to take a while because it's compiling the machine learning model, right? So let's see. As you can see, it even recognized the actual location, right? And if we run it for the second time, it should be faster, hopefully. All right, let's also see image classification. Other than like specifying the task, we can also customize like which model it is. So for the very specific thing we want to do, there are multiple different models and architectures. So like depending on our domain, we can choose whatever model is best. So let's see. In this case, we get a number of predefined categories that the model is trying to assign to the image. All right, so this way we can like explore the different possibilities. But the beautiful thing with smart cells is that now we can just go and see all of the underlying code, right? So, let's see what's going on here. We are loading the model, just as we did before, from a different Hugging Face repository, which is a model that should work with images. And this time we also have a featureizer, right? So just as we had tokenizer to pre-process text, we have a featureizer to pre-process images. So it's going to take care of like scaling the image, resizing, normalizing the pixel values, all this. And then we are also building this serving pipeline, right, using this image classification function. And other than that, we are also having some additional options which tell the serving how to compile the model. But this is like very NX specific thing, and it's just for efficiency, so we don't need to worry about it for now. And then there is this whole second section, which takes care of this UI. Okay, so let's break it down. We use the Kino package, which interacts with Livebook and tells it like to render inputs or certain components. And in this case, what we do is we render a form with an image input. Then we render a frame where we will be pushing the results. And we subscribe to form events using this Kino listen function. So whenever the form is submitted, this function over here is going to be run with our image. And what we do then, we just create a tensor from this image, which we receive as a binary data. We pass it through our serving pipeline, so to do all of the heavy work. And then we use our custom Kino Bumblebee component to render this nice list of predictions. Right? And if you think about it, this whole part over here, it is sort of similar to a live application, right? Where we would have some sort of UI and then invoke the serving pipeline to do the classification in this case. But there is one key difference, which is that Kino Listen is sequential, right? So it means that each form submission is going to be processed sequentially. So to make it more realistic, let's convert this smart cell to code. And we can change Kino Listen to async listen, right? So what this is going to do is that each form submission is going to spawn a new process, which is going to concurrently invoke this handling logic. And having done that, there is one issue with this code, which is that here we call NX serving run, and it immediately loads the computation. So it's going to take the image, place it on a GPU, run the computation. And the issue is that if we have like 10 concurrent clients, each of them will call this NX serving run function. So they will still wait for each other, right? Because only one computation can be running at a time. Okay? And we can do better because the underlying tensor operations that we do, they are very good at doing data parallel work, right? So what this means in practice is that if we took inputs from 10 clients, stack them together, and run the computation for all of them, it would take pretty much the same time as it takes for a single input. Okay, so what would be the ideal architecture in this case? It would look something like this, right? We would have a serving process, which is like our server, okay? And then each client, which here is denoted as live view, would first do some pre-processing on the client side, that is on the live view side. In this case, we would convert an image into a normalized matrix of numbers. Then we would send this matrix of numbers into the serving, so an input ready to be passed to the neural network. And the serving would wait for multiple clients to send those inputs. And it could be like a window of 100 milliseconds or until we have like enough inputs that we can, stack them together. And then we have this, we stack them together into this like what we call a batch. We run the computation, take the results, and distribute them to the corresponding clients, and the client can do like any sort of post-processing that it wants. Cool, so that would be the ideal architecture. And the good news is that we need like just 2 simple changes to our previous code to make this happen. So the first thing we need is the serving process, all right, that's going to like orchestrate all of this. And generally we would put it in your like application supervision tree. In Livebook you can use Kino start child, which is going to start this process under the Kino supervision tree. So we want to start an NX serving process. We want to pass the serving. And we also need to give it a name. So let's make it my serving. as in the diagram. And we also need to increase this batch size over here, and this indicates how many inputs we want to run at once. Okay, so let's make it 8. Run this. And when we run this, it's also going to compile the model up front. So the first request to the serving is also going to be served efficiently. Okay, and now that the process is running, the only other change we need is changing this NX serving run, which was the issue, into batched run. Right, and instead of passing the serving pipeline, we just specify the process name. Right, so let's see if it does what it's supposed to. Right, still working fine. So it's exactly what they had before, but now it's optimized for multiple concurrent clients. Okay, and like since we are talking about those efficiency concerns, there is one very relevant point, which is in production, if you have like a large model, you generally don't want to run it on the same machine as your web server, because the machine learning part is usually very resource hungry, right? And those are like two very conflicting workloads. Okay, so ideally we would take this machine learning workload, move it somewhere else to a separate machine with a GPU, and we would scale those independently, right? We may have like 10 instances of the web server and maybe just 2 nodes with the machine learning stuff. And the beautiful thing is that with NX serving, as long as we connect those machines into a single airline cluster, we don't need to do any changes at all, right? So this batched run function, it is going to look up serving process with the given name in the whole airline cluster. And if there are multiple of those, it's going to load balance the work between all of them, right? So like all of the communication is handled transparently for us. And then a sort of follow-up question would be, what if the machine with the machine learning workload has multiple GPUs, right? Can NX like leverage this? And the answer is sure. We just need one simple change, which is to say that the NX serving should be partitioned. So if we do, if we specify this option, NX serving is going to like load balance the work across machines, across GPUs. And this is why we say that NX serving is so-called distributed squared, because it works on those 2 different levels of distribution. All right? So now we know how to load a model into Elixir, and we have a context of how NX serving works and how to apply it to your application. So now to see it actually in practice, I have a quick demo. So this is running on Hugging Face spaces. And Hugging Face spaces basically allow you to run any sort of Dockerized project. So this is like just a regular Live application with a Docker file. And the cool thing is that with Hugging Face spaces, you can customize the hardware. So in this case, it's running on NVIDIA T4 GPU. Okay? And this is a very simple chat application, chatbot, with 5 different machine learning models inside. And, you know, we could type messages, sure, but this is boring, so we are going to do audio transcription. So let's see if it works. Hello, how is it going? All right. So we use the Whisper model to do this transcription from audio to text, and then we have another model which answers the questions. Okay, so fantastic. I'm in Lisbon, in Portugal right now, and I'm giving a presentation about artificial intelligence, sort of. And as you can see, it recognizes the places in the message, and based on the message sentiment, it also does this like reaction thing. So maybe the like answer itself, it's not ChatGPT level, but like the reaction is something ChatGPT can do, right? And yeah, and like one more thing we could do is we can send it an image, because you know that's the way we do in chats. And as you can see, in this case, it even recognized that this is the particular Dark Knight part of the Batman series. All right? So now to sort of like bring this presentation home, let's have a quick look at the code. And this is like just a regular Live application. So there is nothing fancy there. I will just make it a little bit bigger. Okay? But the relevant part is that if we scroll down here, we make calls to like those magic functions in the Chai AI module, all right? You can see over here, And this is very similar to those functions which we saw at the very beginning of the talk, right? That was like our objective, how to implement those kind of features. And now if we go back, if we go to this try AI module, which should encapsulate most of the complexity, since that's the smart stuff, all of those things are like, 14 lines of code, basically, those features, right? And the whole complexity is like this mapping from emotion to emoji. Right? So for example, in the transcribes case, we just do the batch run just as we did before, and we unwrap the result. And other than this, we have functions that do the loading part, so they load the corresponding models, build the servings, and then we use this in our application file to start the servings under the supervision tree, right? And even with like all of this loading boilerplate, this whole module is 140 lines of code. So that's all it took for those 5 different machine learning features to be integrated into our application. And yeah. So one thing, so this is like pretty much it. But one thing I highly recommend to do is to check out the Numerical Elixir GitHub organization. We have this nice new homepage that outlines all of the different projects in the ecosystem. And there's also like a huge list of resources with videos, articles. So if you're interested in the space, like those are the resources to go to. And also if you have questions or just want to like be up to date on what's going on in the machine learning ecosystem, in the Erlang Ecosystem Foundation Slack, we have the machine learning channel. So feel free to join there and hang out with us. Yeah, I'm happy to answer any questions, and that's it.
Any questions? Yeah, I'm blown away by the talks today. Like, I'll need a week to process. Anyone? This is so big that I don't think I see everything. Oh, it's there. Yeah.
Thanks for the good talk. Like, this sounds like something that can be used already tomorrow. But what are the production drawbacks or bottlenecks that you have seen at scale, if anyone is using this at all?
Yeah. So, okay. The question of like whether it makes sense to use in production can be broken into 2 separate questions. So the first one is, do you want to run like the machine learning stuff on your own, right? Especially like that over the recent months, the machine learning APIs are becoming cheaper and cheaper, more powerful, right? So that's the question. But like one concern with using external APIs is that if you have like sensitive data, you may not necessarily want to send it to an external service. And then the second question is, should you use Elixir or perhaps you should use Python, which is like more established, right? And like I would say that in terms of training, we are still like behind Python. So if you need to train your own model, you may still need to defer to that. But in terms of deployment, with all of the features of NX serving, it is actually a very viable solution. Because now, like, instead of developing a separate service, and figuring out the communication, the API, you just have Erlang distribution, and it works. So yeah, that's what I would say.
Anyone else? Yeah, back there.
Hi, thanks for the talk. I have one question. So if I download a model from Hugging Face, can I enhance it somehow, or is there any easy way to do it?
Yeah. So far we've been like focusing on this sort of loading and deployment side. But sure, you can pre-train a model, like take a model that exists on Hugging Face and then fine-tune it using your own data. And we have an example in the docs of how you can do that. But long term, we also want to like streamline this experience of training so that it's just as easy as loading the model. But this is like one of the next steps. Yeah.
Cool. If there's no questions, I have one of my own. Actually, we have a few minutes. What would you say were the main challenges when building Bumblebee?
Right. So like the very first challenge that we ran into was like how to load the parameters, because like if we go back to those files, this file over here, it's serialized parameters using a very specific Python format. So you can think of it like Erlang term to binary, except it's Python. And the worst part is that in Python you can define custom classes, and those classes can have specific like custom logic how the objects should be serialized and deserialized. So deserializing some of this even requires like reverse engineering Python libraries, essentially. All right? But we managed to do it, and we have like a package called unpickler, which allows us to load this pickle format. And then there was like a second thing I would say was challenging, which is once we started to implement very large models, which was stable diffusion, we ran into some issues that, for example, the computation would block at some point. And the issue is that there are so many levels at which it can go wrong. Like there is, Axon implementation, NX, then it's like EXLA in Elixir and XLA, which is like the lower level technology. So like narrowing the problem down would oftentimes be sort of challenging, but it also allows us to like improve Axon and also like NX itself, bringing those large models into Elixir. Yeah.
Thank you. Yeah, there's one at the back.
What's next for Bumblebee? So what's on the roadmap?
So one thing which is going to be sort of continuously on the roadmap is adding implementation for more models. Because in order to load a model from Hugging Face, we need to have an implementation in Bumblebee, right? Because it's like all in Axon in Elixir. So we want to add more of those. And then the second point would be doing like more streamlined training, which is what I mentioned, so that you can easily bring a model, like throw some of your own data and just fine tune for the specific data so we can use it. And yeah, and then like once we add more models, we can also explore more tasks, right? So in addition to all of those tasks that we, oh, I don't have the smart cell. But like in addition to all of those tasks, there are more things that are possible, so just keeping on extending on those.
Yeah, we have last one, yeah.
Yep, correct. Because like those are models which usually come with papers. So somebody like does some research and there is a new state-of-the-art model. So we need an implementation, and then we can just load the parameters from Hugging Face.
So yeah, sorry. Yeah, we are at time, so let's give a big round of applause to Jonathan.
All right, let's see if I reach this microphone. Okay, so thank you for that introduction. I'm Lars Wikman, as mentioned, and I need a little bit of help, so I need a show of hands. Who has seen or read any of my work before? All right. Who here has listened to Beam Radio? All right. Who knows that I help companies recruit Elixir developers? Sweet. It's a tricky thing doing things online. You get very little feedback on the specifics of what you're doing, especially podcasts, because there's no mechanism for feedback there. Cool. So I run the Underjord site, but I also run a small consultancy. My team is over there and over there. Say hi. They're also on the slide. And if you need any reinforcements with your Elixir projects, we are happy to talk. It's just reach out. But that's not what this talk is about. This talk is an evolution of something I have been trying to do since the 90s. So, since the 90s, I got into computers and I started programming. First ran into C++, and that's when I got internet access, and I've been trying to get computers to do what I want since then. I have even run into HTML. And I never did computer science. I'm entirely self-taught, and I've learned by building things. So when I started with C++, I went by the book, and I built some client or command line applications, very cool, like files and writing inputs and stuff. It was very impressive. And then it tried to tell me about objects. And I thought, finally, I'm going to get to put something on the screen. I can build something cool like Microsoft Office Publisher. And it didn't happen. They were talking about some other type of object, so I dropped C++, garbage language. Then I learned about HTML, and it was super easy to put buttons on the screen. Clearly, a superior programming language. Now, as I've run around just building whatever tickles my fancy, I have run into, over and over again, things that are just frustratingly hard to do. And it's been a little bit unclear to me whether that is because cool things are naturally hard to do, or hard things are naturally cool. But I keep wanting to do cool things with software, so I keep running into difficult problems. And to talk about a little bit about how I tackle building things, experimenting and learning, I think we need to figure out a theory of cool software. This is absolutely a pause for effect, and not just me hoping that the machine learning model will do the right thing. I have fallbacks. Slide forward. Rough. There's an arrow key. So, I posit in my theory that to make cool software, you need to take an input or generate some kind of input, and then you need to transform it. Then you need to produce a different but also interesting output. Now this can describe almost any piece of software, so we need to take it a bit further. It will also need to produce an emotional reaction in a person. So surprise, delight, anger, happiness. Sometimes it can be just one person. It can be you. Sometimes writing cool software is kind of lonely. But yeah, it's necessary. But that's not quite enough. Not all pieces of software that cover this ground qualifies. So what does qualify as cool software? Cool is contextual. It's in the eye of the beholder. So
anything that you know currently or is kind of learning but haven't fully grokked yet has the potential to be cool. Things that are way outside of your league still, kind of, you don't have the experience to grok, or you really don't have the interest in, they have a hard time being cool. Something can be kind of too advanced to be cool. Things that you are just about ready to learn, and you kind of got the big picture concepts, and you're ready to dive into, that has a pretty good chance of being cool. And the things that you know really, really well, the things you do every day, they're not cool to you. Take the CRUD app, for example. When you build like 5 to 10 of those, oh, excellent, an alarm. When you build 5 to 10 CRUD apps, they stop being cool. But to the person building their very first app, they're magic. So, because we're all very serious professional developers here, right? Very, very serious. We sort of look down on chasing the shiny thing. It's very immature. You shouldn't do it. It's bad. I kind of want to argue in defense of chasing the shiny thing. Because just by definition, whenever you're trying to do something that you feel is cool, you are exerting yourself. You are trying something that you don't currently know. I think there's a lot of value in that. No one that I've heard of picks up the guitar and goes, I want to play dependable chords in a repeatable and reliable fashion. That's my goal. People pick up the guitar because they want to play a cool song or make music. And learning how to play an instrument takes years of active practice. Anything that serves as motivation to keep going and keep practicing has a lot of value in that context. Programming is the absolute very same. It takes years of practice for the skill to become effortless. Now, as you grow in experience, many developers start to apply constraints to their craft, and kind of for sport, or they get into like distributed systems, formal methods, or zero trust computing, or what do I know, code golf. Or they go for like the hardest problems of all, which is the human side, like management. But then they stop coding. I don't really do this for sport. I just want to build things, and I don't want to be a manager really, because I want to do coding. So I build these experiments, and I keep trying to learn things. But why do that in Elixir? So I find Elixir to be kind of exceptional at dealing with outputs, transformations, inputs, transformations, and outputs. So you can do all the normal ones. You can do like APIs, and you can do your web hooks, and you can do your files and your web forms. But since I've started with Elixir, I've also explored things I never thought I'd poke around with. So input events on Linux, like raw, low-level input events, USB HID devices, chatbots as UI, hardware with sensors and buttons. And it all follows the same pattern. It all uses the same abstractions. The act of pulling an API for updates has never met a friendlier and more useful abstraction than the Gen server, because almost every time you want to talk to an API, you also need to keep track of a bunch of states, like your auth status, or the previous result to figure out if something new is happening, or the rate limits. And the Gen server just lets you bring that straight in. You don't have to add like a database and validation and schemas and yada, yada, yada. You get this really lightweight, really easy to prototype approach. And often the prototype lasts all the way to production, as we all know. So it also brings us Phoenix, which, well, it's a nice web framework. It does everything I need it to do. But I particularly like Phoenix PubSub. because that gives me a standard way of saying, oh, I got this input here. I'll throw it out to whomever it may concern. I don't really care where it's going right now. I'm working on the input. But it's got to go somewhere, so it goes to a topic, a Phoenix Pub sort of thing. This loose coupling makes it very easy to wire together inputs, transformations, and outputs. And building on the beam, I don't really need to bring in extra things like RabbitMQ or Redis. So I can stick to whatever the beam gives me. I don't need to spin up any worker processes at the OS level. The beam has everything I need in that regard. Now, for output, we have been given a great gift. We have been given live view. It's hard to communicate the difference between the past before live view and how much less work it is to just communicate something and build a live web UI that reacts to new information. All it takes, some familiarity with HTML, CSS, and usually a sprinkling of JavaScript. And it is also a mean source of like inputs. You can do anything essentially the browser requires of you. So where does membrane come into the picture? It struggles with this one. Slide forward. Thank you, Whisper. So, examples of inputs and outputs. So I recommend everyone look at Erlang's WX library. It's a weird one, but it allows you to do cross-platform, desktop, native applications, and that's kind of neat. Then we have, of course, Livebook that everyone has already talked about, which apparently, beyond being collaborative code notebooks and great for teaching, now you apparently can just ship those as apps to different providers. So there's a lot of energy behind Livebook, let's just say. Then there are, of course, chatbots, which I mentioned. So Slack, Discord, Telegram, pretty easy to integrate with, all in all. And of course, if you need to deal with hardware, so sensors, buttons, displays, you can work with nerves, which I rather like. So personally, on my desk at home, I have this calendar gadget. So it's an e-ink display strapped to a Raspberry Pi Zero, and it shows me what my next calendar event is and my current calendar event is. Pretty straightforward, honestly, but actually kind of useful and very unobtrusive. I have also built like a macro pad, which is a small keyboard that I use to control lights in my office. Now, both of those have been almost deprecated because I bought a Elgato Stream Deck Plus. I don't know if you've seen these devices. You get 8 keys that are also programmable LCDs. And you get this LCD touch strip that you also get control over. And then you get 4 knobs that you can do twisty things with. So control your volume, your lights, whatever. And they also click. So you get all this stuff and you can control it from Elixir, or at least you can if you're stupid enough to. There was not a library originally, okay? And the default software does not support Linux. There are some open source options, but of course I decided to build my own. At last year's ElixirConf Africa, I also talked about chatbots as UI. And at that point I was shelling out to Python to get kind of some neat responses to my chatbots. And yeah, those are some examples of kind of what I've been doing with inputs and outputs. So, membrane. I think the slides got out of order, but that's okay. Now, if you've ever done audio or video on the web, you know that it's difficult, you know that it's hard, it's frustrating, you're dealing with opaque formats. So what you do is you grab a FFmpeg and you go and Googlesmith your way to this command line piece of wizardry that you just paste into your app and never touch again. It's essentially write-only software. And that's not a fault of FFmpeg necessarily. It is a domain that is just very complicated. There's a lot of need for performance. So you need a lot of kind of tightly written software, and it all gets really messy. What Membrane does is it takes this wizardry and it breaks it apart into discrete components that you can then put together into pipelines that are very flexible and let you do almost anything that you want. And actually, we should enable the waveform. Happens. So the way Membrane does this is that sometimes it does it in Elixir. Every single element is controlled from Elixir, but sometimes they also talk with FFmpeg through NIFs. Sometimes they use other libraries, whatever is necessary. But they break apart the media processing process. And it is built for live streaming, so they tackle a very hard problem first. Live streaming is a very difficult problem. It's a very annoying domain. Live requires low latency. Live requires robustness. Those are Beam traits. So taking the Beam seems like a pretty good idea, and then building on that. And by trying to solve for this really hard problem, they built a framework that is very flexible and capable of many other things. Primarily really cool and really dumb experiments in my eyes. So, for example, you can work with things like time-elapsed and the progress. You can do things like measure audio levels and indicate them, or even creating waveforms. Actually, we could bring out the fancy waveform. No, the fancy waveform. Thank you, Whisper. You can do things like slice out particular images. You can cut out small pieces of video. You can mute. You can delay. You can bleep. There's so many things that people should be building with it. It is also fully cool theory compliant. It has inputs called sources. It has outputs called sinks. And it has transformations called filters. Now, let's unpack transformations a bit. So, in many cases, if you just take some input data and you output it in a different place, you're just shuffling data around. Sometimes you need to do that, but it's not particularly interesting. Most of the time, though, you need to take multiple inputs and you need to synthesize some new interesting output, or you need to transform it significantly. So there are transformations that are quite easy, like taking a piece of text, cutting it down, just truncating it, or taking an image, scaling it down, or maybe taking some text and putting it in an image and then doing something with that. Well, at that point, you start to need a special library. I would recommend the Elixir image library. It's really cool. It does a lot of fun stuff. And Membrane, of course, allows us to do this for audio and video. It's more complicated than images for sure, but it does allow us to do it. Now, there is a new way of dealing with unfriendly formats. Actually, there's a new way of transforming unfriendly formats, because if I don't say the exact right thing, it will not move forward. If it hasn't been obvious, you can't have a conversation right now without talking about ML. I'm very sorry, but that's the case. Beyond the hype, like I'm not a big ML enthusiast, but there are some undeniably useful utilities in these models. Particularly this kind of weird world of math allows you to deal with some really messy formats. Particularly human speech comes to mind. And turning that with some reasonable degree of accuracy into text. But there are other kind of utility models that we sometimes take for granted and sometimes don't know about. So OCR, grabbing textual information out of an image. Or face detection, which can, of course, allow you to kind of crop in on a face in an image, which can be really nice. Or you can play around with adding filters to landmarks and faces. Or you can bootstrap your surveillance state, which can also be, I guess, neat. There's also this weird thing with turning textual descriptions into actual images. So this is the stable diffusion thing. It has very low accuracy in terms of achieving the result you want, but it is fundamentally capable of doing that, and that's kind of interesting. Now, you can absolutely get access to all of these things through the original tooling. So machine learning requires fast tools, fast languages, and a bunch of math. And I stick to the kind of pre-trained open source models that I can actually understand. Because I want to build things. I'm not here to particularly learn all the math. And I've done that through Python, just shelling out to Python. I used to be a Python developer, it's fine. It's not a particularly great experience, but it's doable. You can do it when you need to. But this brings us to Bumblebee. Because Bumblebee takes the promise of numerical Elixir, NX, and it makes it much, much easier to use. So you've already seen examples of this, but they launched with Stable Diffusion, GPT-2. They've added more things, like, for example, Flan T5. I know Sean Moriarty is working on Llama, so I guess we're getting large language models as well. For this talk, I'm obviously using OpenAI's Whisper. It is one of the most useful models in my eyes, especially since it makes actually accessibility more accessible. Because it's really hard when you're doing a lot of audio and video, like I am, to actually transcribe all of it. That's not something I do, but it becomes possible now. I should also mention eVision. So those are the OpenCV bindings by Coco. Super cool project, super useful, and actually, if I lean back a little bit, I might actually find my face. Hey! Surveillance state. But it also allows you to do things like super sampling for upscaling images. It allows you just the whole slew of OpenCV features. And if you've ever looked into OpenCV, it can do a ton. There's also a ton of machine learning models in there. All right, slide forward. All of this stuff has a lot of complexity to it, and most of these tools are about managing that complexity. We have the fortune of running on the Beam, and if you're working with the Beam, you usually don't need any extra infrastructure, which is nice. Sometimes you need to put it on a server, but that's about it. So we're doing media handling. It's well abstracted, it's very flexible and powerful. We're getting machine learning, also well abstracted, and without knowing any of the math and without understanding the models too much. We're doing live web UI, also well abstracted, with a ridiculously small amount of code. And we get communication and coordination between these things with a kind of high-level standard method. We have message passing, Beam things. Fundamentally, this makes hard things easier, which pushes the boundaries of what is cool and what is challenging. And I think the Elixir ecosystem is kind of uniquely positioned to do that. You can see a cool startup like Supabase take the capabilities of Phoenix and sell them to ecosystems where like real time is actually difficult. Okay, good for them. That's a good idea. You should try it. But fundamentally, I think Elixir as an ecosystem has this capability of building high-level abstractions for really complicated things, partly because we are building on top of Erlang and the Beam, which are high-level abstractions for really complicated things. but also because we have a kind of cultural willingness to push boundaries and try things that couldn't work elsewhere. And that's an interesting thing. So if you try to do something the industry standard way, you risk lowering yourself to that standard. That's not really that cool, is it? So, I guess most of you have figured it out, but like this presentation itself is a little bit of a cool software experiment in my eyes. Actually, it ceased being cool a while back because I've been working on it for a bit. But I'm trying to demonstrate a case of taking multiple inputs, transforming them, and producing some fun and interesting outputs. So let's look at what this presentation is actually doing. Let's unpack this presentation a bit. No, whisper, come on. Slide forward. I could not script this. Okay. So we are measuring audio levels, and we are taking that, and we're getting those as messages. We're sending them on to a live view, and the live view is turning it into an SVG. That's what you're seeing scrolling past on the screen. I'm actually doing a stupidly complex variant in enabling and changing the waveform. So if I say disable waveform, it goes away. And because of who I am as a person, it's not just a flag that's getting set. I actually recompiled the module that renders the SVG, because we can do that on the beam, okay? We can change our entire application at runtime, and I think we should experiment with that more. No, but we measure those audio levels, we produce the waveform. We also do live transcription, poorly. And we do one low latency, kinda near instant, poor quality transcription. You see that pulsing. That's using a 1 second chunk of audio, which gives very little context to make the right call. Then there's a slower but better transcription, and that uses a 5 second chunk of speech. And we use that transformation from audio to text to implement voice commands. These are not really that complicated because it's essentially like string contains. This is all running on a CPU. It has no active cooling. It's a lightweight laptop. If I was running it at my workstation at home, actually I gave this talk at a remote meetup, or a previous version of this talk at a remote meetup in Krakow, and then I could do it from my workstation. I could use a much, much better version of Whisper. So you get these models at different levels, and I have a solid GPU in that machine. This is the tiny one. I'm doing occasional face detection using eVision, and whenever it detects my face, it will draw that rectangle and put it on the screen. The rectangle is also SVG. Now everything is just messages to live view, updating the state, pushing it to the client. It's the same thing anyone using live view is doing. It's just a matter of what are the inputs, what are the transformations, and how do I make the output interesting. Fundamentally, it's parlor tricks mixed with a bunch of potentially pretty useful stuff. I hope that, if anything, you take away from this talk is just a sense of possibilities. There are a lot of cool inputs out there. There's a surprising amount of potential transformations these days, and there are a lot of ways to produce an interesting output. And the trick after that is just creatively bashing things together over and over again, building a muscle of creativity and creation until cool becomes effortless. Thank you for your time.
Thank you very much, Lars. So yeah, we can't have questions now because we'll be jumping on to the lightning talks right after. So yeah, thank you again, Lars. Great talk, amazing. this one.
Okay, and
And that one, yeah. Or we also... Just turn it on there. Up.
So all three mics can't be live at the same time.
This works, yeah. Yeah, I think we can.
Yeah. Cool. Welcome everyone. Welcome back. Yeah. So we'll now move on to one of the most exciting parts of all ElixirConfs, which is the lightning talks. Always surprising. And a lot of things we can learn in 5 minutes. So we're starting off with Alistair Woodman from the Erlang Ecosystem Foundation and his lightning talk around community engagement. So welcome Alistair and Francesco to the stage. Yeah.
Hi.
Yeah. Do I get a mic too? Okay, that's all fine. Okay, we got 2 mics. Okay, let's get going.
Okay, hi everyone. So I'm Francesco, founder and technical director at Erlang Solutions, but I'm also founding member of the Erlang Ecosystem Foundation and have been on the board of directors since, well, we set up the foundation in 2019, I think it was. We announced it, yeah.
So these are our current board members. We do have an election going on at the moment. So for those of you who are members, please get on and put in your vote. I do want to make a shout out to Fred Hebert. He's stepping down. Some of you guys would have known what he's done and worked on, and he's been very useful on the board. He's a exception. I'm personally very sorry that he's stepping down and we're going to lose him, because he's been very useful in terms of keeping us on track and focused on good things. But anyway,
he'll still be focusing on good things through the work groups.
I think so.
Which is exactly what happened when Jose stepped down as well from the board. So it leaves him more time to get us into trouble.
Exactly. So this is an update on our membership. And since these numbers were published for the AGM last year, we've had pretty linear growth. So we're over 1,400 members now. And I think we're going to start, we usually see upticks of membership and people getting interested in joining when we have conferences and events. So that's certainly one of our sort of observations to you is like, join. It's not that expensive. It's
actually free.
Become a member. Yes, just become a member. So sign up.
Yeah, and you can sign up through the earlyf.org website. Yeah, it's free, and you get access to the Slack channel, all of the groups and so on, and we'll say more about it. Now, we have also a section of membership which consists of paying members, but I think a large part of the donations come from our sponsors. We've got companies who are able to sponsor, and we've got 3 tiers. I think the smallest group is for $3,000, $5,000, and $10,000, which is the minimum donation based on the size of the company. And these are all of the supporting members who allow us, we have 31 sponsors in total, and it basically allows us then to go out and use the funds, not only to run the foundation, but also to pay for the infrastructure, but also most of it gets handed out in stipends, which we're going to look at in a second. So if you have employers, go tell them, join them. If you've got the buying power and the decision power, it's a few $1,000s. You should, if you can sign it up, just come speak to us afterwards.
Yeah, I do think I would encourage it, and I'll talk a little bit later. One of the points I've got related to EU regulation, and I do think you need to be interested. We do need to form lobby groups. We do need to be associated with that. So it's in your interests, both you and your company's interests, to be involved with the foundation. These are the 12 working groups we have active at the moment. It's fair to say that COVID wasn't very kind to some of them. So now that everybody's getting re-energized and active about things, that is a plea to get involved with working groups if you're interested. Quite a lot of useful work has been done by people collaborating in these environments, and I'd encourage you to get involved. If you see anything here that tickles your fancy, please sign up and become a member.
Great, and I think see these working groups as a collection of contacts, and it's an amazing contact network. we found, prior to setting up these working groups, that there were, 3 or 4 different activities and 3 or 4 different people independently trying to solve the same problem. This is a forum, for everyone to come together and actually solve the problems once and not, 4 times.
Okay. One of the major things that the board does with the funds that we get is to actually hand out these stipends. This is only for the last sort of 12 months. It's not covered everything else because it wouldn't have fit on the slide. We're handing out somewhere in the region of about 50,000 a year. And it could be more if you have useful and interesting things you want to do. We do want things to be working generically for people in the community. Last talk that I was in this room, Coco's libraries were mentioned, and there's a bunch of other useful things that we've had going on in other areas, including the JIT work and other things that we've sponsored, which I think everybody benefits from. So we're not looking to pay and fund very vertical niche things. We're looking to get things working that benefits the generic and general community. But as you can see, there's a very broad list of people who've gotten involved here, from academia to individuals and companies, and we're willing to listen to any suggestions that come our general direction.
And on top of actual work, I think a lot of stipends go to diversity and inclusion at conferences, yes, at events, training, and so on. We've got an amazing work group which kind of focuses on that, and so we channel the funds through them.
Right. I think, I did want to mention that as well. There's over 40 people attending remotely here, which is part of the diversity stuff. And we are very focused as a community of getting diverse groups involved. And we were sort of very supportive of the event last year in Africa, and anywhere else that you want to get involved in bringing other people into the community. We see that as one of our jobs. It keeps coming up as a topic that whenever we talk to businesses, it's always, where do I get developers from? So we're very interested in trying to get the next generation of programmers involved from all walks of life and all locations. So this is a bit of a left turn on this. I don't want to spend too much time on this, but we are in Europe. The European Union has currently got something called the Cyber Resiliency Act that it is promulgating, and they're very interested in making sure that people who write software don't write crappy software, and that it doesn't affect people's lives. So basically they're representing the interests of the voters, and they want to make sure that people's information doesn't get stolen, their identities don't get stolen, their content from video cameras doesn't get sent to the wrong parties, and they want to make sure that people are held accountable and liable for this. So if you're familiar with the concept of the CE mark, they're trying to drive this into the software supply chain. If you're building software for your own business purposes and you're going to be selling it, it will bite. This is going to happen in Europe. I'm very interested in talking to people about the open source aspects of things. We as the Beam are actually an open source project. I think we will ultimately end up having to have the infrastructure and technology in place just to provide CI/CD infrastructure and the ability to be able to do supply chain management for software in order to be able to support these needs. So if anybody's interested in this space, I'm spending a lot of time at the moment in Brussels talking to other foundations and other groups that are interested in this type of thing. Please come and find me tomorrow. I'd like to network on this particular topic. That's what I'm very focused on at the moment. Anybody actually heard of this? Hands up. Okay, that's good. Okay, so anybody who hasn't, and if you think you need to pay attention, come find me. I'll give you the elevator pitch. And that's it. So parting request, please join a working group. Please become an EF member. And please talk to your employer or company and get them to become a sponsor.
Yeah. Thank you.
Yeah, so next up we have Tom. Yeah, cool.
Use this mic or can you use? Yeah, okay.
So yeah, please welcome Tom Calloway to the stage on We Solve Optimizing Software Delivery on the fly.
Hola, bon dia, good nacht, good afternoon. My name is Tom Calloway. I'm going to talk about optimizing software delivery on the fly for teams and individuals. We exist on and can't escape from a constantly advancing timeline. We're forced to prioritize now versus later, and it can't all be now. We might do our best in a deep workflow, but by its nature, we become unconscious of time passing. Our minds imagine more than we could ever do, and though visions form in an instant, to enact them, we are forced to build them linearly, sequentially along a timeline. After we extrude a specification into existence through sheer force of will, our castle in the sky appears, but it takes steady, long-term effort. This Kanban app, as in Kanban with more fiber, includes a game that substantiates benchmarks and illustrates some of the optimizations that it attempts on team processes. This is an example. We can't keep starting tasks as a way to overcome whatever is our current inherently limited capacity. Some teams use tools that are highly optimized for their profession, which helps optimize that part of the overall process for delivering business value, but it doesn't encompass the whole system boundary of the organization, so it excludes other participants, and that means that it will be suboptimal. Elixir is built on Erlang, and Erlang is named for Agner Erlang, the founder of queuing theory, which is a branch of operations research. So we have a legacy here. So the Kanban web app is designed to help organizations and individuals measure, maximize, experiment with, and predict their work. Aggregation of tasks into towering projects is not the only way. An alternative is to adopt an experimental portfolio value approach. I definitely recommend Teresa Torres there at the bottom and her continuous discovery habits. It brings together product and engineering in a nice way, and uses a tree structure to break down and communicate and show the connections between hypotheses and outcomes. And that's what I try to express here in this way of capturing a backlog. Work composition and work process are destiny in terms of your output, your production. This is an example of, on the left, listing the stages in your process, and on the right, starting to include some more variables that typically are not present, specializations of actors in your process. Every time someone has several choices, there's a significant probability that they made a non-optimal choice for the process as a whole, simply because they don't have granular visibility into the whole system. We might think we're playing checkers or backgammon when we're actually playing Go. Kanban is not necessarily the answer, but it is a means to find your answers for your team and your data. Here is assigning the skills to individual actors, so the system can match them up for stages they're eligible for. In theory, there's no difference between theory and practice, but in practice there is. A web framework comparison, where years ago I looked at program size for the real world app, commonly implemented in back-end, full stack, and front-end frameworks because I was trying to choose one. And this is the relative sizes of several front-end frameworks that I looked at. After standardizing by removing comments, et cetera. Vastly different differences. Okay, 1 minute, I'm going to speed through this. Any measured value includes a world in it, accounting for all the phenomena affecting it, even the ones we're ignorant of and don't yet understand. It's the only way to align all of our hypotheses, deductions, beliefs, mental models, and simulations. We can create telemetry for our own execution. Just like with Elixir, we create spans. Our Kanban boards can be actually more interesting and rich to express our full process. But yet simple and focused, yielding lots of data that we don't normally see about ourselves. Agile Manifesto talks about uncovering better ways of developing software by doing it. I include A/B experimentation, relying on Bayesian statistics so that you can get answers earlier than the traditional methods. And with a GitHub Copilot experiment, I'll have to give you the results later. It was not as big of a difference as you might expect. Oh, there's the data. Outlier at the top. Many things we could experiment on: coffee, tea, Gleam, Livebook, unit tests, test first, test last. Finally, here's some links. Thank you.
Thank you, Tom.
Next up we have Arjun, sorry. So, yeah, your slides are here.
So maybe I can just use this.
So yeah, let's start up with the next one. Arjun, Arjun, sorry.
Hey, my name's Arjun Gillard. I am a recruiter at a company called Understand Recruitment in the UK. You'll have to bear with me. I have no slides. I only found out about this at 12:30 this afternoon. So I have put together a very short talk for you all. My talk is about how it is difficult to hire Elixir devs in 2023. So, a little bit about my background. I'm a failed engineer. I studied computer science for a year at York University. Really didn't get on with it, didn't enjoy it. Studied archaeology instead. Was a little bit better at that. Thought I was going to dig, become the next Indiana Jones, right? Didn't happen. So, what did I do instead? I fell into recruitment. I didn't know what I wanted to do. I thought I'd be good at it. 12 years later, thankfully, not blowing my own trumpet, but I'm average to good, I guess. I've been in tech recruitment now for 4 years. I've been recruiting in Elixir for the last year across the UK, US, and EU. So, I've helped companies from startups to large multinationals, scaling from placing founding engineers to building teams. It's so community-based. It's incredibly community-focused, and it's growing considerably. It's the second most loved language, according to Stack Overflow 2022 report, right? There's lots of benefits to it. There's concurrency, there's speed, there's scalability. There should be lots of developers in Elixir or wanting to learn Elixir. Thankfully, there are developers who want to learn Elixir. The challenge is, when hiring in Elixir, is the pool of candidates and pool of developers is extremely smaller compared to other languages. So, here are my tips for hiring Elixir devs in 2023. The first one, consider different languages. Right? We've placed developers who have come from Node, they've come from Ruby, they've come from Erlang, they've come from Clojure, they've come from Rust. Allowing people to learn on the job would definitely help. I've spoken to so many people today who are self-taught Elixir. They've learned on the job. It can be done, it's proven to be done, and from my knowledge, they sound like pretty good developers. So please consider that. Tip 2, hire remote. If you can hire remote, please do. Distributed teams as well. Several companies I work with, they operate typically plus minus 3 hours of a specific location. Others are operating more on a worldwide basis. According to LinkedIn, and please take this with a pinch of salt because it is LinkedIn, there are 1,000 Elixir developers in the UK, 7,300 in Europe, 5,700 in the US. Not everyone has LinkedIn, so we have to take it with a pinch of salt, and some of the people that I found on LinkedIn say that they have Elixir experience. When I actually talk to them, they're dabbling in it very slightly. Tip number 3, don't be hung up on education. You don't have to have a degree to be a great dev. Personally, I've placed so many developers that are self-taught. They have boot camps. Some have been to university. Thankfully, it's making my job a little bit easier. More companies are coming round to the fact that you don't have to be degree educated to be a strong developer. Tip 4, candidate experience is key. This is a particular bugbear of mine because I love giving as much information to candidates as possible. I love giving feedback. I hate giving feedback of, yeah, they're not interested in you. Why? I don't know. They wouldn't tell me. So, please give feedback throughout the process, even if it's negative, because it will help the developer learn for their next interview. And also, aim for feedback within at least 48 hours, because no one likes waiting around, right? Another thing, tip 5, marketing. Put out content. Get people wanting to work for your organization. Write blogs, record videos, interview your hiring managers, interview your engineering managers. Tell people why they should want to work for you and why they should be bought into your vision. Tip 6, retain people. It's very difficult to hire people. It's very difficult to retain people if you're not regularly reviewing salaries, ensuring that you discuss their career aspirations, giving regular feedback loops as well. The developers that I speak to a lot of their frustrations that they have with their current companies are, I don't know where my career is going. I haven't had a pay rise in a year, maybe even 2 years. And then they go to leave and the current company says, here's an extra 5K, here's an extra 10K, please stay. If you do this each year, if possible, appreciate people have budgets and companies have budgets, but if you can do it, please do, because it will keep your developers engaged and interested in continuing to work for you. So, to summarize, hire from other languages, hire remote from different countries if possible, ensure you have a great candidate experience, streamline the interview processes, post content, and most of all, be flexible. Thank you for listening. Feel free to reach out to me if you want to find out a bit more information about how I can help people, the Hoover app, or find me on LinkedIn. My name is Arjun Gillard. Thank you.
Thank you. Thank you. So next up,
it's that one.
You want to handheld or this one?
Too much choice. Hello. Yeah, that one's fine. Yeah. Okay. Yep.
I'll give you a sign when you have 1 minute left, okay?
Okay, great.
Let's. Oh, sorry. Yeah, let's.
please welcome Paul Wilson to the stage.
Hi, I'm Paul Wilson on the stage. So I really like messing around with nerves, you know, embedded Elixir on single board computers, that kind of things. And I also like to have my nerves boxes communicating with something on the cloud so I can check things when I'm away from home or control them from, over the cloud. And WebSockets are great for that because it's two-way communication. But I keep finding myself writing variations on the same code, so I've made FedEx. Is that a recognized FedEx? Messenger of the Gods from Done Manifesting? Yep, cool. So, how to do it? So, FedEx server, it's a hexical. I'm the only person who uses that term, but I'm sticking to it. Stick it in your server dependencies, the FedEx server. Implement the handler as a behavior, which has callbacks for things like authentication, handling messages coming up from the client. When a client connects, so you can use presence to track the client, or subscribe to messages, so you can push things down to the client via PubSub. Subscribe to PubSub and shove things down to the client. And then, stick it in your endpoint. There's a handy FedEx socket macro, which will set that for you. I was messing around with some existing code to screenshot in a convenient way, and I've got no idea how that parenthesis ended up on the alias, but there you go. On the client, FedEx client dependency. I only shoved this up actually this lunchtime. I've been getting it off GitHub. Documentation is a little sparse at the moment. Promise I'll put something, I'll do a bit more. Then there's a handy use macro to implement on the client. Fill in various things like where your server is, device ID, other optional callbacks are available. Then stick it in your supervision tree. Easy. Then you can send messages to the server. So this is on the little box on my office, which is checking temperature and checking presence of people. I want to turn it into like a burglar alarm thing at some point, where it texts me when somebody breaks into my office and takes photographs of them. But I haven't got quite around. I get sidetracked doing stuff like this instead. One-time login. I tend to have a little local Phoenix app running on my Nerves clients, which I can connect to and do things like log into the server. It's one time, and that's it. So FedEx, things it does, it'll automatically reestablish the connection if when your network goes down, which it inevitably does. After the initial authentication, it'll store a signed token behind the scenes, so it'll reconnect using that. Pings the server now and again, and the communications with Elixir terms. So Joe Armstrong heckling somebody about using JSON once. It's like, no, just use Elixir terms. Decoding is safe, so be careful with your atoms. And no credentials are stored locally, so it's a signed token, which you can do the expiries, configure the expiry, things like that. Thank you. I'm Paul. That's me. I'm not hiring. I'm the opposite of that. Yeah, hit me up.
Thank you, Paul. Cool, now we have Sebastian. Let's welcome him on stage, yeah.
Hello, everybody. My name is Sebastian, and today I'm going to talk to you about K6, the open source load testing framework from Grafana. And I have two objectives today. I want to quickly tell you what K6 is and what you can do with it, and also how it integrates with the Elixir ecosystem, and especially LiveView. And then, if you're interested, I have some suggestions for improving the library, which I'm about to do. And if you want to help, then feel free to hit me up. With K6, as I said, it's a load testing tool. So what you can do is you can implement HTTP GET. And as you can see here, K6 is written in JavaScript, so you need to write some JavaScript for this. But nonetheless, you implement, for example, in this case, a HTTP GET, and then you sleep. And if you execute K6, what you get back is a very fancy way of telling you how the load test went. So what it will do, it will spin up very many virtual users, which you can configure. So you can say, I want 100 parallel users hitting my app, and then you can implement workflows of what these users are going to do. And afterwards, you get a report of what they actually did, what your numbers were, so you can specify specific timeouts, you can actually increase the users and decrease the users, so you can say, well, I have a spin-up period where the users go up and they increment a little bit and then they stay very high and then they drop a little bit again. So in addition to just testing like 100 users for a short period of time, you can also do this concurrently over 30 minutes, for example, to see if you have any memory leaks in your application or any other stuff which comes up when there is a high load over a long period of time instead of just like 100 users and then it's gone again. In Elixir, we have this nice Elixir K6 library, which was developed at SpawnFest 2021, I think. And what it does, it's a neat little wrapper. It downloads K6 in the background. It gives you some mix tags, so you don't need to interact with K6 directly, but you can just type mix run K6, mix K6 run, something like this. And you'll also have some templates which give you a little bit of a scaffolding for REST, GraphQL, LiveView. They have a lot of templates which give you a little bit of a kickstart, but then they don't actually help you any further. So there's where you need to come in and actually implement all the specific stuff you want to do. And how this looks with a live view is, for example, like this. You can actually send events. So K6 doesn't have a browser, so you cannot actually click around, but you need to do what the JavaScript in your browser does. So for example, send events to the live view. And in this type, we send a chart init event, and then you need to handle the response. And this is where it gets ugly, because this is how it looks like for us. If we want to evaluate the response from LiveView, because what LiveView gives you back is the actual thing. It needs to render the HTML, so it's not actually an API which you're supposed to consume just like a REST API, but more for the LiveView JavaScript part. So there you run into problems, or at least it's ugly. And as soon as you change the HTML, this breaks. So you need to go into your developer console again, and then need to figure out where this value is again. So this is where I would like to actually, my vision currently is to see if we, if somebody wants to join, can get in and make this nicer, add a little bit of JavaScript helpers, which can automatically generate it from the live view, and then provide some neat little helpers. So to, instead of this, get to more of a, get me some kind of feedback from the server, and then I'll be, then you can evaluate it. I'm not sure if this will work and how it will work, but I'll try. And if you want to join me, get in touch. Otherwise, try K6. It's a great library, even without the new stuff on top. It's currently working very, very good. We use it in production, or not in production as in we hit our production, but we hit a pre-production environment with it. And yeah, awesome. Thank you very much.
Thank you, Sebastian. Yeah, you. So yeah, please welcome Daniels to the stage. Yeah.
Hello, everyone. So today I'm going to talk about IEX. I think you know what that is. So very last minute. So you might be familiar with IEX, and it's a really amazing tool in the Elixir toolchain. And today I'm going to tell you about IEX.exs. It is this really amazing file that you can put in your home directory or in the root of your Mix project. And the cool thing about it is that it acts like a regular Elixir shell that gets evaluated every time you start up IEX in your project. But there are some neat little tricks I want to show you. So let's go into this very basic sample project. Is it big enough for you guys? Just awesome. So let's just start a normal Elixir shell. You can see it already says that it loaded in another IEX file from my home directory. And we can do some cool things like, that's the wrong name, like find out how many atoms we are using currently in our running Beam instance. That's great. You can define modules and functions in your .iex file, but you can also do other things like define convenient functions like CLS. You can do things like define restart, and this just restarts your entire Beam instance. You can even do things like do queue. And I love to do this because I come from Erlang and I really miss queue. So what's the deal here? So let's look at my IEX file. So as you can see, we can define a convenience module called util. We can define a few helper functions like atom status, CLS. This clears the screen. We also have help. And this is where the magic starts. So you might know that in Elixir script, every function needs to live inside of a module for you to be able to call it. There is a trick if you want to call something like CLS without needing to specify a module. You can create a variable, bind an anonymous function to it, and use the annoying dot syntax. But you can define a module like this with an underscore, give it some kind of name. This is very optional. Then you can use the delegate macro, delegate this to something a bit more complex, like a specific module that already exists in Elixir or your own custom one. For example, here with util, we can define CLS. We delegate it to util CLS, which we define up here. And it's literally just an io.puts call. So very simple stuff, but extremely convenient. To help you out, there is a gist I published. I work at Platogo. We are hiring Elixir devs. And this is my website, danpetro.xyz. Thank you for listening. Hope you got something out of it.
Thank you. Really interesting. Next up is, okay. No, yeah, it's fine. It wasn't my order, but yeah, it's nice. So yeah, just the HDMI.
Hello? Oh no, it's gone sideways. My screen's gone sideways.
Is it there? Yeah.
Yeah, but look at this.
Oh. You wanna maybe a different adapter?
I'll try a different adapter.
You have something to allow.
Let whoever's up next, let them go on. I'll try to fix this over here.
Can you try? You want to try this one?
I think it's my laptop, so I just tried 2 different ones. So whoever's to go next, I'll try to swap.
Okay.
Fix it.
So yeah, we need to actually follow the order. Andre, yeah, let's come up.
Let's see if my... Extend mirror. Oh, come on. Oh, no, it's working.
Cool.
So,
Yeah, fala para o mic. Acho que a malta rima pronto a conseguir. Ok.
So yeah, please welcome Andrea to the stage. Yeah. Apparently not yet.
Decimate. Este.
Experimenta esse.
Os que não são originais da visão.
Now we're business. Yeah, cool.
So,
So yeah, take us away.
we have 5 minutes, so instead of 1 demo, I will try 2. Doom Guy visits the BIM. So I think you have all heard about supervision strategies. So we have 1 for 1, 1 for all, rest for 1, and the dynamic supervisor that replaced the simple 1 for 1 strategy. They look like this, right? But instead of going over diagrams, let's see them in action. So you will need to believe me when I say the BIM is connected to the. Let me start the game. Okay, let me get to my supervision place. We don't have much time, so I'm using sheets. Sorry for that. Okay, and so now let's spawn a supervisor. Okay, here we have our monsters. We spawned a 1 for 1 supervisor, right? So if we kill one of them, another will appear on its place. Let me try to increase the size of the window. Or maybe not. Let's kill this supervisor and use the other one. So, okay. Let's spawn now the 1 for all supervisor. Okay, spawning it. So this one for all, right? So if we kill any of these processes, all the others will die and the supervisor will respawn them, right? Fun stuff. Let's kill the supervisor again. Okay, and finally the rest for 1. This one is interesting because the supervisor, you'll see in a minute. So if we kill the third one, right, only the ones on the right will die. But if we use the BFG, which has ripples, right? So we kill the first one on the middle, then it all die. So the supervisor is trying to stabilize them, right? And only now they are all set. For the dynamic supervisor, I will need your help. So please get your QR code reader and go here, please. Let me. And you should be able to. Oops, sorry. Were you able to go there without my game crashing? Yeah. So you should be able to spawn some monsters. No? Are you clicking? Oh, and Grok is failing on me. I swear this worked. No, but I have some users here. Where are you? Ah, one. At least one is here. Let me kill your monster, sorry about that. So, well, this was a failed attempt of showing you a dynamic supervisor, okay? You would be connected with live view, and monster would be spawned by the dynamic supervisor and would be killed. So I think in 5 minutes I can, oh, we have one big one. Okay, cool. So sometimes it works. If you want to know more about how it does all this works, please let's talk afterwards. You can find the code, both the patch I did to GZDoom and the Elixir code on there. Thank you.
Amazing. Thank you, Andre. So, yeah, Roland, yeah, please come up. Yeah.
I thought I'm helping by using that laptop.
No worries, no worries. So yours, yeah.
This one.
So apparently that's there, but I think it's
thanks.
Right.
So yeah, let's welcome Roland.
Can you make sure it displays?
Oh, that's a nice idea, yeah. This is straight at HDMI. Just here. Yeah. Cool. So yeah, Roland, take us away. Thank you.
So welcome to this talk on property-based testing with Elixir. My name is Roland. I'm a director of engineering at Community, and I'm also the extreme digital nomad. I write code always and everywhere. This is my van. If you want to talk about community or extreme digital nomading, come and see me afterwards. Lightning talks can be either enlightening or lightning fast. I'm totally aware that I am between you and the beers, so I try to do both here. In 1973, the rock group Focus was asked to perform their song Hocus Pocus on NBC Midnight Live. The song is almost 7 minutes long. The slot they got was 4 minutes 30 seconds. They did not shorten the song. They played it faster, much faster. And the performance was enlightening. So let's go. Motivation, when we do testing, we obviously have input values and we have a function, we get output. And we are looking for valid test cases, invalid test cases, edge cases. We are looking for good code coverage. In 80% of the cases, the unit testing that you do will give you 80% of the value, and that should be good enough. But in some cases, you can actually test something that is much more interesting and better, and that is you can actually test all valid input values through the function against a set of properties that the output should adhere to. Yeah? So that is very valuable and actually very low maintenance and creates good code coverage. So meet property-based testing. Property-based testing is not new. It was invented a very long time ago, and the most famous implementation is by a very famous computer scientist called John Hughes from 1999 in Haskell for Haskell, and is called Quick Check. There are other implementations of property-based testing frameworks, Quick Check like for Scala, Clojure, Rust, Go, and also for Elixir. The two big ones for Elixir is PropCheck, which is a wrapper around PropER, which is the property-based testing framework for Erlang. And then there is also Stream Data by Andrea Leopardi. The two main concepts in every one of these property-based testing frameworks are generators and properties. Generators create the values, properties check that the properties are good. They actually work together to create a very nice feature of the frameworks. It's called shrinking, because sooner or later one of the tests will fail. But it will probably fail with a very complicated set of input values. Shrinking actually goes backwards and tries to find the simplest possible set of input values that makes the test fail. Yeah? Very valuable feature and something to think about. So let's do a quick example here. Pascal's triangle. Some people might have seen that. Every row is the sum of the two values in the row above, yeah? And it creates a triangular array of binomial coefficients. And the triangle has a couple of very interesting properties. Every row has one element more than the previous row. Every row is a palindrome, yeah? And the sum of all elements in a given row is double the sum of all elements in the previous row. Yeah? There are much more properties. You can, let's say, an exercise for the reader if you want. So let's talk about palindromes. I give you 5 seconds. So 3, 2, 1. Let's dive into some live coding. Let me switch the laptop. Just kidding. Let's take a look at that. Let's take a look at this at the unit test here, and we have a nice unit test for row number 4, which should, let's say, return this set of values. So far, so good. We obviously want to test maybe some edge cases, like what happens on row 0 or the first row here, and that should obviously work. But then we can also try to say row 99 should be a palindrome. Yeah? But that's not really what we want. What we actually want is we want to test a property. And we want to test the property that for all positive integers, the resulting array of numbers is actually a palindrome. Yeah? So, and if we run this, long and behold, suddenly the test fails. Yeah? And it basically gives us a couple of very interesting numbers here. The first one is it had 58 successful runs. Yeah? So it was already testing for a while. Yeah? But then suddenly, when it was trying 42, it failed because whatever it got back was not a palindrome. Yeah? So if we take the look at the code here, then we can immediately see that Roland implemented a bug. Yeah? So, and we can remove that bug and everything will be fine and the world is going to be a better place. Yeah? So if you want to do property-based testing, do not force it. Yeah? It works well for a subset of problem domains, mainly math problems, pure functions. Do not look at it as an alternative for your traditional unit testing, but more as a way to complement your existing unit testing and make it more comprehensive, more complete, and easier to maintain. Last key takeaway is if you want to learn more about this and all of the other ways to do testing, just buy the book from Andrea and Jeffrey. Yeah? And otherwise, sleep well tonight.
Thank you, thank you.
Hello, I'm Hector, and I'm going to talk about how to improve democracy and how you can help. Just that, huh? Simple.